Hello students, my name is Arun. As we have discussed earlier that we will be just going through those chapters which we should be considering more. So this is our first video which we will be dealing with matrices and determinants where as you know the weightage is more. Fine. So here we will be dealing with 5 years previous year question paper where the main purpose of this one is for those who have already completed and set for you to write the exam. For those, just go through the video, just surf it and just see those questions what has been asked, and also if you know it, try to do it once, pause the video and check whether the answer is correct or not. And for those who really don't know how to handle this exam or what need to be studied, metrics, obviously these two chapters are gonna give you 13 marks, so make sure that each and every single mark counts. So let's make sure that from this video, if you guys are not thorough with the concept, you will get a clear idea about what is being asked till now and also what will be asked through. In this set of videos for you, we have systematically arranged all the questions like 1 mark first, then 2, then 4 and 6 from 2018 to 2014, so that 5-year question paper. So and at the end of the video, just make sure that you watch that questions which is so important, which I have set based on so many sources. So make sure that you work those questions in all the videos to be followed. We will first do 2019 sample question and then 2018, 2017, like that, the previous year question paper we will do. And we will do full start off with the 1 mark question. And the first question is, if A and B are invertible matrix of order 3, A determinant is equal to 2 and AB inverse determinant is minus 1 by 6, find the B determinant. That is what the question is. That is a very easy question, but it is not in the textbook, but make sure that you just follow the same steps here. Now what is given here? AB inverse determinant, you know what that is, minus 1 by 6, and it's been given that it's at order 3. Okay, fine, no problem. A determinant is 2 and you are supposed to find the B determinant. Fine, cool. Now this one, now can I write AB inverse determinant as 1 by AB determinant, which is again equal to 1 by 6, just like A inverse is equal to A, just the same way I just drop in the denominator. So 1 by AB determinant is equal to the same value what is given in the question. Now I have a formula here. AB determinant is nothing but finding first the A determinant, then multiplying with the B determinant, isn't it? So that's all you already know. So I'm gonna split this one. So what I will get here is 1 by determinant A into B determinant, that is again gonna give me 1 by 6. Fine, which implies already I know the value of A, which is 2. So I can write here, or else you can take it, you can cross multiply and then you can substitute the value. It's fully up to you. If I substitute, it will be 2 determinant of B is equal to 1 minus 1 by 6, which in turns give me determinant B is equal to, very careful with where you are taking all these values. Okay, determinant B goes up here, the minus sign, the minus 1 goes down, so it's gonna be like, if minus sign going up or down doesn't care too much, but there need to have a minus sign. Then 2 is already there in the denominator, then the 6 will go up in the denominator, and thus when you cancel, you would able to get the value of B determinant equal to nothing but 2 1 time, 3 time, it's gonna be minus 3. So minus 3 is the value of for be determined. Fine. It's quite easy, I think. Then quickly jump on to the next question. Question number 2. Just make sure that you keep on writing the notes, or one who doesn't know all these things, make sure that you keep all the formulas you get in a separate page. Okay, make sure that it be more systematic way, because it's hardly like 14 to 15 days left. On to 2018 board exam question, 1 mark. The question number 4 is the metric question, where it is given if the matrix A is equal to 0a minus 3, 2 0 minus 1, b 1 0 is a skew symmetric. Find the value of a and b. So here you are supposed to find the value of your a and b here, a and b. Fine. This is a very easy question. You need to know first of all what is skew symmetric, and if it is skew symmetric, you need to know what we can do with that. And according to the question, it's been said that this complete matrix is a skew-symmetric. So I can write its A transpose is equal to minus A. This is what you need to keep it in your mind. So A transpose is equal to minus A. Fine. That means you know how to transpose this A matrix. And if you don't know how to take A transposes, nothing but you need to interchange the rows and columns. The columns will become the rows. Okay, now this first column will become the first row. So 0, 2, B, first one. Then the second column, 1, A, 0, 1. Then the third one, minus 3, minus 1, and 0. Thus, I got my A transpose. And if someone is asking me what is A minus A, I'm just writing this one for the sake that you are just starting with the matrix here. That's why. Otherwise, I would have skipped this step and directly would have written it. But for your better understanding, I'm just writing it. Minus A means this is already A. So minus A gives you this. 0 becomes 0 itself. A becomes minus A. Minus of minus 3 is 3. Minus 2, 0, again 0, minus 1, thus becomes 1, b becomes minus b, 1, minus 1, 0, 0. Quite evident right there. Fine. Now it's been said, as I have told you, that this is skew symmetric matrix. These two are gonna be same. So what I can write here, so this matrix 0, 2, b, a 0 1, minus 3, minus 1 0, this is gonna be equal to this complete this matrix, which is 0 minus 3, minus 2, 0, A, minus B, minus 1, and 0. Clear? I think it's pretty much clear. Now you need to compare the two matrices, because it's been said that it is equal. So A is over here. I can compare with the same, so that element in that specific place, where in the first column and second row. So that same element is over here as 2, minus 2. So what is the value of A? A is nothing but minus 2. So if you compare, this is gonna be giving me this minus 2. Fine. Just in the case of B, you can compare this B or you can compare this, not an issue. Minus B is equal to minus 3, this gives you 3, or else B and this element you can compare and gonna give me value 3. So B is nothing but it's 3. So these two are the values what you are expected to find for this 1 mark question in 2018. 2017 board exam. The first question was from matrix. The question was, if for any 2 cross 2 matrix, 2 by 2 matrix, A at A into at J is equal to matrix 8008, then write the value of determinant A. Fine. So A at J is given here. So A at J, if you don't know what is at J, You definitely need to go through your textbook, need to understand, or else you need to wait for the 4 mark question so that you get a better understanding of what is this adj and all. So a into adj is equal to, it's given that, what is the value of the elements down there in the matrix? 8, 0, 0 and 8. This is the matrix what I have. Fine. Now a at j is nothing but, we know that, what is a into at j? At j is nothing but, it is a determinant into I. Fine, you know this one. Finding the value of determinant of a and then multiplying with a I will give you a into at j. So in that case I can write here, because what I'm supposed to find here, determinant of a. So here I can write determinant of a determinant into I is equal to what? Nothing but 8008. Clear? This is what I'm having. Now again, determinant of ai is equal to nothing but, you can take away this 8 from here, right? So I can write 8 into, what is gonna be the determinant then? If 8 goes like, it's just like you multiplying it inside, you are taking it out, you are dividing it by 8, you're taking it out, so 0, and this becomes I. What is this matrix? This is nothing but your identity I, right? So determinant of a I is equal to 8I. From clearly from here itself we can write it like what is gonna be determinant of a. So determinant of a is nothing but 8. Clear? This is answer for this question for 1 marks. Moving on to 2016 board exam question paper, 3 questions were asked. 1, 2 and 3rd was the questions from matrix and determinants, and this is the first question. We'll solve this one and then the other 2. Fine. The first question, if a is equal to, in matrix it's given like cos alpha, sin alpha, minus sin alpha, cos alpha, find the value of alpha if satisfying, what is the range? 0 and 0, and it would be that alpha should need to be in between 0 and pi by 2. Pi by 2 is nothing but no, right, it's like gonna be 90 plus when this condition is given. So what is the condition here? That means a plus a transpose is equal to root 2 I, that identity matrix of order 2. Fine, this is given. You are supposed to find the value of alpha here. Clear? Now go ahead, substitute the value of a here. A is gonna be cos alpha, sin alpha, minus sin alpha, cos alpha. Then need to be added with which one? A transpose. Now I don't need to write the separate ones, right? So just simply interchange the rows and columns. You will get cos alpha minus sin alpha. Then the second column, this column becomes this row, sin alpha and cos alpha. Here is given, and that is equal to root 2 I. I is nothing but 1 0 0 1, in this case 2 by 2 matrix here. So this is given. Now I'm supposed to find what? The value of alpha. We need to add these two together. So what I will get here, when you add these two metrics, I'm gonna get 2 cos alpha, this term with this term, okay, this term with this term. So sin alpha minus sin alpha, it's gonna be 0. This one again will give me in turn minus sin alpha plus sin alpha 0. Cos alpha plus cos alpha will give me 2 cos alpha. Fine, this is what I'm getting when I'm adding this, and that's supposed to be equal to, when you multiply inside you will clearly get here, 1 becomes root 2 0, this becomes 0 and again root 2. Now generally sometimes I have seen students have a tendency of multiplying this one, now multiplying, finding the determinant and then finding this determinant and getting the value such like that. No, this is matrix where you need to, there is one matrix given on the left hand side, there is another one which is given on the right hand side, and these two things need to be compared. So elements need to be compared on the same row and column. So in this way I can clearly get to know that 2, the first one, is equal to root 2. So 2 cos alpha is equal to root 2. That's what I will get from here, which implies cos alpha is equal to root 2 by this 2 will come down, isn't it? Which if I want to, I can multiply both the sides by root 2 and root 2. Thus what I will get here, I will get here something cos alpha is equal to 2 by root 2 by 2 root 2, which 2 and 2 get cancelled. What I'm gonna get 1 by root 2. So cos alpha is equal to 1 by root 2. So alpha is nothing but cos inverse 1 by root 2. What is the value of alpha, where I'm gonna get a value 1 by 2? Nothing but pi by 4. So isn't it satisfied, this one? It is between 0 and pi by 2. Fine. This is the answer for the first question in 2016. Now moving on to the second and third then. The first one, if A is a 3 cross 3 matrix, AB determinant is equal to K A determinant, then write the value of K. Fine. This is the other question. First we will solve this one. But what is given? A is a 3 by 3 matrix. Yes. So here again and one more, 3A determinant of that one, which is actually a 3 by 3 cross matrix, that is equal to K A determinant. Fine. Now on these type of question, I need to make you understand that 3 into a vector is that 3 would be multiplied with each of these elements. Minus of any matrix, you are gonna multiply this minus 1 into all the elements of that matrix. It is not same as over here in determinants. So there is a property that if you multiply, you will be multiplying it entire row or entire column. But as it has been given here that 3A, that means the 3 will be there along the entire determinant. So in that case, if I make you understand this logically, I'm gonna take first 3. Okay, I will write here 3 into 3. Now determinant of A is equal to K determinant of A. Why? Because I have taken this 3 from the first, because it's a 3 by 3 matrix. So it will be like this, 3 by 3. So each elements are here. So the first 3 will be out from here. The second one be from the second row, or third from the third row. You can think like that. So these 3 came out. It's not like just the 3 which you write it like this, 3 determinant of A. No, it is simply wrong. Fine. So it must be like this whenever you see a problem like this. You need to take it 3 times. If it is of a matrix 4 cross 4, so you need to take it 4 times that particular number outside. So in this question, what I will get is, this is gonna be 3 into 3 is 9. 9 into 3 is 27. So 27 determinant of A is equal to K determinant of A. From here, what is the value of K? K is nothing, which is implies K is nothing but 27. So this is the answer for the second question of 2016. Now on to the third one, 2 from the matrix. I have told you 3 questions in 2016. Now the third one, a set of like 3 equations I've given. The first one, this one, yeah. Here we have the second one, and the third one. So we have 3 equations given, which is asked. What is asked to find here? Has a unique solution. So now there is a mistake what I have written. not A as 4. Okay, it's 4. Fine. So here this equation I'm supposed to find the unique solution of this. So whenever a question is given that the solutions are unique, that means it is not equal. So you need to find the determinant of that particular those values or that particular determinant you need to find, and which must the answer what you get should not be equal to 0. So if it is equal to, then it's a separate case, it would be equal. But in this case, to get unique solutions, the determinant what I'm gonna make with these equation must be not equal to 0. So this determinant as from the equations are, this value is 1, 1, the second one is again 1, then the third one 1, then from here the second equation 2, then here 1, and from here it's gonna be minus 1, right? From here minus 1, then on to the third equation 3, then 2 and k, and this determinant should not be equal to what? 0 if it is a unique solution. So it is already been given as a unique solution, so this is not equal to 0. In that case, what is the value of k? Fine. Now if such a thing is there, an equation is given, what you can do is that you can now find the determinant value, or else what you can do is that you can just make some of them by column transformation 0. Better than row transformation, column transformation is important, and you will get an idea over here what is row and columns, because yeah, I will do it columns, okay, because as the question paper goes on, we'll get more questions on row and column transformation. So over here, what I'm going to do here is that the first column, this is my second column, right? So second column, I'm going to interchange with, I'm going to subtract it, like C2 minus C1. I'm going to subtract with this column. Why? I will tell you the reason behind what I'm doing it. And C3 also, what I'm going to do is that C3 minus C1 is what I'm going to do here. Fine. Now my intention of this one is to make these two zeros. When I subtract it, what I'm gonna get, okay, the first column is gonna be the same, the second one is gonna be changing to 1 minus 1 0, 1 minus 2 it's gonna be minus 1, 2 minus 3 is gonna be minus 1 again, isn't it? Now from here subtract it from the first column, 1 minus 1 0, minus 1 minus 2 is going to be minus 3, k minus 3, k minus 3. Fine, this is going to be not equal to 0. Why I did so is, now if I try to figure out the determinant of this value, this need to be multiplied with this and this, then minus of 1, then these two things elements, then from this one plus 1 into these 4, so that will be a hectic big number. So if I subtract it, I can easily figure out that the second ones, the second and the third term just vanishes. I just need to expand it along R1. So expanding along R1, the first row, what I'm gonna get here is, okay, I will write it here, then I will write one more step here. So if I gonna expand this one, what I'm gonna get, 1 into, okay, I'll write the entire steps, okay, 1 into, this is gonna be minus into k minus 3, minus into k minus 3, minus 1 into minus 3, this into this minus, okay, minus into inside bracket this the element into this element. First we multiplied this, subtracted by these two, then that's it, which is not equal to 0, because the next two terms are gonna be 0. So from here, okay, one more bracket close, that is for the 1. From here I can easily get, now k should be like minus should be multiplied inside, so it will be minus k, okay, I will write it here this side, that is equal to minus k plus 3 then minus this one gives me 3, again minus 3 is not equal to 0. From here what I'm getting, minus k, these two things just vanishes, this one like again vanishes, and this one is giving me, this is 0 is not equal to 0. That means k is not equal to 0. So this is what I'm getting. So the value of k is what? It should not be equal to 0. Could be anything else. Fine. This is the solution for the third one. You just write the determinant first and just vanish these two elements from the top. Then you get to expand it very quickly and find the value of k. Fine. So this is question number 1, 2 and 3 of 2016. Then move on to 2015. Write the element A12 of the matrix. A is equal to, is given AI, then is a 2 by 2 matrix whose element Aij are given by Aij is equal to e raised to 2ix sine jx. Yes. Now we need to understand what is this I and j here first of all. Now this is a 2 cross 2 matrix. So it's a 2 cross 2 matrix where you need to know what are I and it's normally we would say ith row and jth column. So if I am supposed to find the first element, okay, it's like I would be 1, here it would be A11 because first row, first column. So the first one is the row and the second one is the column. Here it would be the first row itself and it would be second column. This one would be first, second row, first column, and this would be second row, second column. So this is basic concept of finding this answer here. What is given here? It's given that Aij is equal to e raised to 2ix sine jx. Fine, this is given here. Where the values are clearly visible, what is the value of j and I and j? Because write the element, this element. That means to say that I need to find this element in this particular matrix. Here this element goes if I find the value. Fine. So how to find the value is just very simple. Substitute I is equal to 1 because that was the first value and j as what? 2 in this particular equation. Fine, that is very easy, right? So in order to find a, then I and j become 1 and 2 becomes what? E raised to, this will become 1, so it will be e raised to 2x. Fine. And the next one would be j sine, j would be 2 here, so it will be sine 2x. So this is what the answer for the A12. Fine, it's very easy, right? Fine. Now suppose like the question, if someone is asking me or asking you what is the value of A22, then what happened to this one? This will become, then this will be giving me a value e raised to I is now 2, j is now 2, so this will be e raised to 4x sine, this one will be the I is I and j, you can remember now, j is nothing but 2, this is gonna be 2x itself. So 2, yeah, then multiplied with this one, yes, this is my A22, but this is what we are supposed to find in this particular question. Fine. This was 2015 question. Fourth question was from matrix, and in 2014, there are 3 questions. So the first one is this: if A is a square matrix such that A square is equal to A, so we know here what A square is equal to A. This one we know. Then write the value of this A. So 7A minus, and I is that identity matrix. So 7A minus I plus A the whole cube. Now I need to supposed to find the value of this one. Okay, so finding this one, What I will do is that I will expand this one. 7a minus, let it be, this is a plus b the whole cube, where the formula, as you know, that it is a cube plus 3a b square or a square plus 3 a. If it is the other one is square, then this one will be the just the opposite, like a square b plus b cube. So as it goes here, the first term cube plus 3 into, okay, I will write for ai a square ia square plus 3 into I square a plus a cube. This is what my formula is. Now, okay, now what is given over here, let's try out with these and what we will come up to. 7a minus I square is nothing but I cube, I raised to 5, I raised to 6, it's gonna be the same, I plus I into a square, we know that it is gonna be a, so I into a, it's gonna be a itself, so 3a plus 3 into here, I square is I into a, again a, clear. Now here a cube, if I want to write one more step, okay, I can write a square into a, right, a, which in turns I can write 7a minus I plus 3a plus 3a, and this will be a into a square, so thus get me a value a, because a square is a, then a and a square, a, fine. So which when simplify inside you will get plus 3 plus 3 6, 6 plus 1 7a. So when I open up the bracket, 7a minus I, then minus 7a, that gives me what? This 7a and minus 7a get cancelled, I will get minus I. So this is my answer for my first question of 2014. Fine, I think it's pretty much like easy. Only the thing which you need to see is the formula. This one you need to know that this is the formula. Once you learn this one, then it's pretty much easy. Fine. Move on to the second and fourth question. I think second and fourth is what is asked in 2014. Fine. Now 2014 we have two questions left, 2 and 4th in that question paper. The first one is based on metrics, the second one is based on determinants. So it's good that I wrote it side by side and you can have a good look at these two questions, and don't do this method or this way over here. Like whenever I have told you previously that whenever you see a question like this matrix, you cannot multiply, cross multiply, and you cannot multiply with this and this, and you can multiply this and write, but you can do it over there. So how to solve matrix? As you know that these two things are equal and you are supposed to find the value of x and y. So these two equations are same, so these elements are also same, right? So I can write here x plus y, x minus y is equal to minus 1, isn't it? Okay, let me this be equation number 1. The second one, 2x minus y is equal to 0 here. So that be equation number 1, and this one be 2. Now what you can do with this one in order to find the value of x, because I need to find the value of x and y here when these two matrices are same. So then I can compare only these two. I cannot compare this and this because that is not having x. And as you can simply tell, someone is asking what is the value of z? Yes, z is 4. What is the value of w? W is 5. But here I am asked to find x plus y. Very clear about it is not x or y. It is asked to find x plus y. Now from these two equations, you can I can get rid of y. I can subtract. Yeah, I can subtract these y, and I can subtract 1 minus 2. If I do it, I'm gonna get like this side x minus 2x is gonna be minus x. These two get cancelled. That is equal to, because minus y minus minus y, so this become minus y plus 1, y becomes 0. Then minus 1 minus 0 is again minus 1. So thus x value is nothing but 1 here. So if I know the value of 1, I can get it very easily. Substitute over here. 1 minus y is equal to minus 1. Minus y is equal to, this will go that side and will give minus 2. So y is nothing but it's 2. So I got the value of x, I got the value of y. What I'm supposed to find here? So this is my value of x, this is my value of y. I'm supposed to find the value of x plus y. So x plus y is nothing but 1 plus 2, which is equal to 3. Fine. This is what I'm supposed to find for this 1 mark question. Clear? It's very easy, I think. Moving on to the last one of this 1 mark question. The fourth one, like if 3x7 minus 2 4 is equal to determinant 8 7 6 4, find the value of x. I'm supposed to find this value of x. Fine. Nothing but just open or find the determinant of the first one there. It's gonna be, okay, I will write the complete step. Okay, 3x into 4, these two together, minus 2 this and this, minus 2 into 7 here, minus, oh no, it's equal to, from the value from here, it's 8 and 4 together, these two subtracted by those two values, 6 into 7. Fine, this is how you do it, right? This implies, gives me, these two things multiplied will get 12x. This one, 2 into 7 is minus 14, minus 2 into 7 is minus 14, then into minus will give me plus 14, that is equal to 8 into 4 is nothing but 32, minus, because these two are plus, 6 into 6 is 36, 6 7s are 42, so it's gonna be 42 here. Now, which implies 12x is equal to 32 minus 42. I will get from these two, I will get minus 10, I think. Yeah, minus 10, then minus 14. So that in turn give me 12x is equal to this one minus 10 minus 14 gives me minus 24. Thus x is equal to minus 24 by 12, that when you cancel one time and two times, so which implies x is nothing but minus 2. Fine, this is my value of x. So these are my 1 mark questions. So let's move on to the second mark, the 2 mark question. Moving on to the 2 mark question. In 2019 sample question, this was the question. 6th question was from matrix. It's been said that if A is equal to 3 1 minus 1 2 and I is equal to matrix 1 0 0 1, find K. So we need to find the value of K, so that A square is equal to 5A minus 5A plus Ki. Fine. This is what I'm supposed to use it and find the value of K. Fine. For that reason, I would take all these, I would find first all these. Okay, A square. So find those things what is necessary for the equation, so that we just substitute it. A square is nothing but square of this one, and how you square? You cannot just square all these elements there. You need to multiply. 3 1 minus 1 2. And how to multiply with the same matrix, or how to multiply with other matrix, that you need to know how to multiply. The first column, first row with first column, second row with first column, first row with second column, second row with second column. So it goes like that, and this I will write. Okay, this is the starting, right? Starting of the multiplication question. So I will write this full steps here, so that again later on it will be easier for you if you don't know multiplication. So the first, now what I'm going to do, this row with this column, the first column, okay, with these two I'm going to write, I'm going to multiply this one. So 3 into 3, 3 into 3. So first element of this one into first element of that first column. 3 plus 1 into, you can put a bracket if you want because there is a minus sign. So 1 into minus 1. Yeah. Then in order to write this one, you need to go for the first row because you know that it is gonna be the first row and the second column. So the first row with the second column. So in order to write this one, it will be 3 into 1 because this 3 with this one plus this 1 into this 2. Okay, 1 2 into 1 or 1 into 2. Fine. This is my second. Then to get this one, this is gonna be your second row with first column. So second row with the first column. So minus 1 into 3 plus this 2 into minus 1. 2 into minus 1. Fine. And over here it will be the second row with second column. So it would be minus 1 into 1 plus 2 into 2. Clear? This is gonna be that matrix, and when you do it, it's gonna be very simple, like 9, and this is gonna be like minus 1 into minus 1 is gonna be minus 1, and 9 minus 1 it's gonna be 8. So this term is 8. Then over here 3 plus 2 is gonna be 5. Fine, I got 5 here. Then over here this 2 into minus 1 is minus 1. Here also you will get to see 1 minus 3, and this one will be minus 3 minus 2. So it will be minus 5. We need to add it. Then here minus 1 plus 4 will give me 3. So this is what the matrix, which when you get it, when you multiply or when you a square it. Fine. So this is one of the which I wanted from the equation. Then chalo, let's go with the equation here, and I hope like you can clearly get that very easily with this. Now I will write the equation again. A square is equal to 5a plus ki. This is my equation. A square already I know what is the value. Value is 8, 5, minus 5 and 3. Correct. That's equal to 5 into a. 5 into a means a is this one. You need to multiply with each of the terms. Now you can just skip with the steps. 5 into 3 is gonna be 15. Yeah. 5 into 1 is gonna be 5. 5 into minus 1 is gonna be minus 5. 5 into 2 is gonna be 10. So I got this one. Plus ki is nothing but I term, which is like over here I 2 cross 2 matrix into k. So that will be, the first one was 1, that will be k now. Second one 0, then again 0, then the k. So this will be that matrix. Fine. Now what? Now it's pretty much easy. Now that will give me, okay, the same matrix. I'm writing it again, so that I can add this one and then you can compare it. So 15 plus k would be the first element. This would be 5 because 5 plus 0 is 0, 5. Then minus 5, then 10, then k plus 10. So this is my matrix when I add these two. Fine. And then now you can start comparing with, okay, I will compare this element, the first two element if you want, or anything like, okay, I'm gonna compare these two first element. Fine. So that gives me 15k or 15 plus k. I'll write it again. 15 plus k is equal to, what is that? That is the first term. This one, first two terms I'm comparing. So I'll get 8. There. So that means, that implies k is nothing but 8 and 15 will go that side, becomes minus 15. So which implies k is equal to minus 7. Fine. So this was the first question, question number 6 in 2019. Let's move on to 2018 then. In previous year question paper 2018, this is the question. 11th question was for matrix. Given a is equal to 2 minus 3 minus 4 7. Compute A inverse and show that 2a inverse is equal to 9a minus a. Okay, this is what we need to show. First of all, we need to compute a inverse. Fine here. Now, what is a? A is 2 minus 3 minus 4 and 7. Fine. Whenever you are asked to find out in 6 mark and all, you will get it, like find a inverse in 3 by 3 matrix, and this was quite a bit easy, 2 by 2, but the approach or the steps what you need to go through is gonna be the same. So first thing what you need to find is determinant of a. Fine. When you find the determinant of a, it must not be equal to 0, then only you will get a solution, then only a inverse exists. Now how to find it? Just multiply. Okay, I'll write it. 2 into 7, right, plus or minus, what is it? Minus 4 into minus 3. That will give you 14 minus, this is gonna be plus 12. So again with the minus, it will get minus 12. Thus you get 2, which is not equal to 0. So that means A inverse exists. Fine. So A inverse is there. So we can find it. Now it's the time to find it. Now first of all, you know to find the cofactor matrix and then transpose it. Yeah, that is gone. Then you are at J. So those things you need to know. So first of all, about the cofactor matrix, like cofactor of A is nothing but, just go with the flow dear. And here you need to know the polarity of the 2 by 2 matrix here, where the first term is having a polarity of positive, negative, negative, positive, just the same way. Okay, the first one, as I told you, the polarity is positive. Then cofactor means just get rid of with these two. That means the element where it is, like the first row and the first column, and what you get is 7. So the first over here, the polarity is 7, the positive, so it's 7. Now the second element over here, where you need to get rid of with this column and this row, where you will get minus 4, but over here the polarity is minus, so minus of minus 4 will be plus 4. Fine. Then over here, this row and this column you need to get rid of. You will get to see 3, yeah, minus 3. Here the polarity is minus, so minus of minus 3 is 3. Then again, what you are supposed to find? You're supposed to find this particular elements, which is gonna be this the opposite, that is 2. Fine. So this is your cofactor matrix. Clear? Now at J is what you need to find next. At J. At J is nothing but transpose of this particular matrix, and that will be nothing but transpose. The column becomes rows, rows becomes column. 7, 3 and 4 and 2. This is what the matrix what I get it right now. Then what I'm supposed to find? A inverse. A inverse is nothing but 1 by determinant A into adj. Adj A. Okay, fine. This is what I am gonna find adj. Determinant of, now A inverse. What is determinant of A? Already we found out it is 2 here, right? 2. It's 2 into this matrix, which is gonna be 7, 3, 4 and 2. Fine. This is what we are reaching right now. 2. Clear? Yes. Now it is, you are supposed to show that 2 into A inverse is equal to 2 inverse 2 times A inverse is equal to, you need to show it. Okay, I will take left hand side first, which is 2A inverse. So thus what I will get here, 2 into 1 by 2, which implies 2 into 1 by 2. What is the matrix? 7, 3, 4 and 2. Thus this 2 and 2 get cancelled. What does my matrix? 7, 3, 4 and 2. This is my matrix. Yeah, just keep it. So I'm gonna check this one is equal to your right hand side or what. So right hand side gives me, what is it there? 9i minus a. What is 9i? This is a 2 by 2 matrix, so 9 0 0 9 minus a is nothing but, a is already we have in the question, 2 3, no, minus 3 minus 4 and 7. When you subtract it, what you're gonna get here? 7 minus 2, 7. 0 minus 3 will be 3. 0 minus 4 gives you 4. 9 minus 7 gives you 2. So that means your LHS is equal to RHS, right? Hence sure. Clear, yeah. So it's pretty much easy. It's not too lengthy. Inverse, you can, once you know how to find A inverse, then it's pretty much easy, man. Easy, you can get this one. Fine. Okay. Move on to the next one. In 2017, they have asked, if A is a skew-symmetric matrix of order 3, then prove that delta A is equal to 0. So I need to prove at the end delta A or determinant A is equal to 0. As it's been told that it's a skew-symmetric, as you know that A transpose is equal to minus A, isn't it? Fine. If I take determinants on both the sides, I'm taking determinant to A transpose determinant and minus A. Then what I'm getting here is that A transpose, which implies A transpose is equal to, if I take minus 1 outside, it will be minus 1 whole cube. You still remember what I have told from each row? Minus 1, minus 1, minus 1. Then thus it could be written as determinant of A transpose is equal to minus of determinant A, which I can clearly write here one thing, that determinant A transpose determinant is equal to A determinant, because even if you interchange the rows and column, the value of the determinant value is not gonna change. So this I can write, which implies A transpose determinant. Okay, I can just clear off this one. Determinant I don't want. A determinant is equal to minus A determinant. Clear? Which is equal to, you can take the determinant to the other side, you can write 2 A determinant is equal to 0, which implies determinant A is nothing but it's equal to 0. This is what they are asked to find. Fine. This was 2-mark question, and hereafter in 2016 and all, they were not having this 2-mark question, so we will jump into the 4-mark question. Okay, we are gonna start with the 4-mark question. Like 2019 sample question paper, I have given this question. We are using the properties of determinant, prove that this determinant is equal to A plus B plus C into A plus B plus C, A square plus B square plus C square. Fine. Here I'm gonna take this one as LHS. Whenever you have a question like this, make sure that you practice well these type of questions here, because whenever you see a question like this, you need to know what to be done at first. Clear? And how to approach it is also very different from person to person, but you need to have your own way to solve it, and you need to understand the question first, then you solve it. Fine. Now here, if I look into the question, it will be like, first I will be searching for what like where I can get an A square. A, B, C, okay fine, I will get it by subtracting it all. I should need to multiply with something to get A square, isn't it? So it will be like the first column when I would look at and start to multiply it with A square, A. So if I multiply, I would take 1 by A outside. Yeah, 1 by A outside, because I'm gonna multiply that A, which could be cancelled with with the entire column. So it will be A square. This will be A square plus AC, and here I will get A square minus AB, and this will be B minus C, B and B plus A, whereas this will be as same as it is C minus A into C. Clear? So this much I have done. Now it's time for me to just bring up all these b square and c square. How? I think like if I multiply this column with b and this with c, I will get b square c square. When add up with this first column, you will get to see a, b and c. Now c1, how I'm gonna change this? You can see like b square, and it's gonna be bc here. And when added with this with c square and cb, that bc and cb cancel. So c1 is equal to c1 plus bc2 plus cc3, and thus what I'm gonna get here is 1 by a itself. Then this one, when you add it up, okay, I'm gonna write the complete term for you to understand. A square plus multiplying this one with b square bc, and this complete column with c, and adding it c square plus cb, and this one a square plus c square ac, b square plus ab plus c square. Then the other terms, oh, b minus c, b and b plus c. These. Okay, I got something like this right now. What next? I'm gonna take a square. Now over here you can clearly see that now this one, it was a like gonna be minus bc. Yes, this and this we already talked about it. It will get cancelled. Then this and this will get cancelled, and this and this will get cancelled. As you go, it will be this term what is left. Isn't it? In these three. And over here, here. So this is what I'm getting all the way down here. Fine. Now, now what I'm gonna deal with next is, okay, I'm gonna take it outside. Even if one step I can reduce it, I would have done it, but it's okay, fine. I'm gonna take a square plus b square plus c square outside with a here already, and inside it will be 1 1 1 b minus c, b, b plus a. It will be c plus b, c minus a, and c here. This is what I'm getting here, isn't it? Yes. And after that, like normally whenever you see a 1 and 1 here, just try to make it 0. How can I make it 0? I need to do two things here. One is c2, no, I'm gonna take r2. R2 is equal to R2 minus R1, and R3 is gonna be R3 minus R1. In that way, if you subtract it from the first row, can't we make these two things 0? These ones, this one and this one, 0. Okay, let's see. Like if we are doing it that way, it would be giving me an answer like this: a square plus b square plus c square by a. Then you have a determinant inside. The first row will be as same: a 1 b minus c, c plus a, c plus b. Then the next would be a 1 minus 1 0, b minus b plus c, it will be c, b and minus b get cancelled, c minus a minus c minus b, so it will be minus a minus b there. Then 1 and this particular thing first, then it will be 0 here, then b plus a minus b, that b and b minus b will get cancelled, then a plus c, a plus c, and this will be c minus b, so c and minus c will go and it will be minus b all the way down there. There. Now if you take the determinant, it's so easy because these two terms you don't need to think, because when you take it now 0 comes, so obviously it's gonna be cancelling, or it will be 0, so you just need to only just look at this particular one. So what I have here is, okay, I'm not gonna take this one, I'm gonna just keep this one over here, and I'm just gonna make you understand what you'll be getting when you solve this one. Okay, 1 into, and these will be like minus cb, we're gonna be minus cb, right? And then minus of this term, which is, okay, if I multiply with these two, okay, I'm gonna write here, I'm gonna multiply, okay, a plus c into minus a minus b. Clear? And if I do this one, you don't need to do like this, okay. I'm just like getting everything into this particular space, so that's why I just don't want to rub it, and I just want to write it again with a completely new thing, which each, if you are getting confused, you want to see where you got it wrong, so that's why. And if I look into this one, and 1 I don't need to consider here, what I need to go through is minus cb, yes, obviously it is there. Now if I'm gonna multiply inside, it will be a and a, minus a will be minus a square, and this with the b it will be a minus ab, with the c with minus a will be minus ca, then over here it will be minus cb. What else now? You're gonna multiply the minus inside, so it will be plus a square plus ab plus ca plus cd there. So what you are getting across is something which I can cancel these two, and this is what you are coming across when you do the determinant of this particular value, or when you expand with this with the first row. So expanding with the first row, this is what you are getting. Thus I can write with the complete thing: a square plus b square plus c square by, you have a 1 here, and with this term multiplying together, ab, okay, I missed out a square plus ca. Now what you can clearly see from here is that now this term already we got it, this term we have done, and now it's time for us to just clarify a bit over here. And if I see that if I take the terms, or if I try to divide all these a, then it's very much the answer here. So it will be a square plus b square plus c square, and I'm trying to cancel this a with all the terms here from here and 1 square, so it will be a plus b plus c. This is equal to your RHS. Fine. Hence proved. Okay, fine. So this is how you prove this type of questions. Let's move on to 2018 previous year question. Using the properties of determinant, prove that this determinant is equal to, determinant value is equal to 9 into 3xyz plus xy plus yz plus zx. Clear? So we have all those numbers jumbled up here, there, and all. Okay, now what we will try to do in this problem is we will try to make some number 0. Like if I do something like this, R2 is equal to, I'm gonna transform it to R2 minus R1. If I subtract this one becomes 0, right? Okay, and then this one, when I do it again with R3, gonna be doing this one with R3 minus R1 same time. So let's hope like we will get through it very easily. Okay, and as when we subtract, what we are gonna get here is this minus this. So first row is gonna be as same as it is, then this minus this, so it will be like 3y, this minus this, it's gonna be 0, 1 minus 1 0 minus 3x here, then one more row is there, 1 minus 1, it's gonna be 0, this and this gonna be 0, and this gonna be 3z, then 1 minus this term is gonna be giving me again minus 3x. Clear? So this is where I end up with. Now k is z, we don't want that. Okay, so like if you have it, like let's try to expand it. Expanding along R1, what we get here. Okay, I will write the complete step. Let's see. 1 into this gonna be 0, and this will give me minus 9xz, isn't it, when I do with this? Yeah, I'll get something like that. Then with minus 1 here, minus 1 into what I have there, these two terms, which will give me minus 9 x and y, xy, these become 0. Okay, then I would have gone for simple brackets, it's no problem. Then the last term over here, this and this, yes, plus I have 1 plus 3x here, this term need to be multiplied with this, which is 9y is it here, 9y is it, and this one, whereas this one is multiplied with only this term. Yeah, here I close the bracket. Fine, so these are the terms what I have right now. This is, so this one, what I did, I am finding the determinant value of this particular thing. So what I can write from here is at equal to, I already have like, so minus of, yeah, it's gonna be like one more thing which I left was minus into this one, and minus of this will become plus 9xy, x is it. So that give me 9x z. Okay, and whenever you stuck with somewhere, or whenever the sign is here, there, and all, always you in these type of question, one thing is that this is what you need to get at the end. So if any sign problem is there, or if any change in sign you get to know that one way or the other, somewhere or the other you got a mistake, so you need to correct it. So 9x is it, and this one multiplying inside, what I will get is plus 9xy, yes, and this one what I'm getting is plus 9y yz. So I get to see all these terms here. Yeah. So I have xz here, which is this, xy, which is this one, yz, which is over here, and each one have a 9. Clear. Then on to this one I have yes plus 27 x, y, and z. From here, what you can take? 9 outside. And thus with this, like this, I can write. With the first term over here, and when 9, 3 is left, 3, x, y, z, plus 9 went outside, it's gonna be the same thing. If you want, you can write it. Which is gonna be what? Their right hand side. So, hence, fine. In 2017, 14th question was from matrix. The question is like using properties of determinant, prove that determinant a square plus 2a, 2a plus 1, 1, 2a plus 1, a plus 2, 1, 3, 3, 1 is equal to a minus 1 the whole cube. This is what we are supposed to prove. Fine. As I have told you that approach is almost the same in all the problems. Here we will try to do is that we will try to build this 1 minus a minus 1 each and every single time, because we need to have 3a minus 1. That gives me a minus 1 the whole cube, right? So let's try this one. If you are doing adjustment with the column, it's gonna be 0 like a square. No, I don't think it will be. But if you try it with this one, because a minus 1 is what we need to form. So if we look at these two rows, first and the second row, then the first row minus second row, you could able to see that a square minus 1. And this one also gives me 2a, 2a, and this one, like, yeah, it will be a minus 1. Yes, so that will be the thing which you would be looking at. So what I'm trying to do here is I'm gonna try r sorry, r1 is equal to r1 minus r2. Okay, let's write this one. This gives me r1 is equal to r1 minus r2. So this complete term minus this term gives me a square minus 1, isn't it? A square minus 1. And this one 2a plus 1 minus a minus 2 gives me again a minus 1. Okay, then 1 minus 1, obviously 0. So now if you try with the next two, that means r2 is gonna be r2 minus r3. What we are gonna get here? This term minus 3. So that will be 2a minus 2, and here this will be a minus 2 minus 3 is equal to 0. And the last term, I'm just writing it just like that. Clear? I think it's fine. I think you don't have much of a confusion. From here, what I can do is, from these two rows, I can take out a minus 1. So it will be a minus 1 the whole square from here as well as from the second. So it will be whole square. And what you will be getting? It's like from here a minus b the whole, a square minus b square. So that will be, what is left here will be a plus 1. And again this term went, so it will be 1. Then 0, you need to do much. This one 2 is common, then a minus went outside, so it will be 2. This complete went outside, it's 1, then 0. This will be as same it is. Clear? So these are the ones which I have right now. So what I will try to do right now. Okay. Now I can figure out something so that I can just get rid of some other terms. For example, what I can try here is I need to get again 1 minus a minus 1. If I try to solve it from here, maybe like you will get it. But if you are like we are use the property of determinants, then it would be somewhat in other fashion, then it will be good, I think. Okay, now let's make this first row again. R1 is equal is R1 minus R2. Again, if I try to do, then it's again gonna be 1 minus a minus 1 the whole square, and this would be nothing but R1 minus R2 gives me a minus 1, a minus 1, 1 minus 1, 0, again this one again 0, and the other terms thus be the same. Clear? That in terms I can take 1 minus a minus 1 outside, so thus I can put this one as a minus 1 the whole cube with 1 0 0 2 1 0 3 3 1 left in the determinant. Now just simply just go through the like, okay, now these two are 0. Now if you calculate the value of determinant, 1 into 1 1 minus 0, so it will be just a minus 1 the whole cube. That is gonna be your RHS. So hence proved. On to 2017 14th question. It's an OR question. So over here you are supposed to find a matrix A such that this matrix into A will give you this particular matrix. Fine. So you are supposed to find with the elements what is matrix A. So for here, this matrix is multiplied with this one. So whenever we think of doing multiplication of two matrices, then we normally used to compare their order, right? We used to see, again, what fashion we used to see. This matrix is in the order 3 rows and 2 columns, right? Now I must, and this out or equal to the output is also in the order 3 cross 2. So the matrix A should need to be 2 cross 2 in order these two need to be equal so that the multiplication is possible, as well as you are getting an output 3 cross 2, which is already over here. Fine. So the A must be of 2 cross 2 matrix of order 2. Fine. So let A matrix be A, B, C and D. Now this is what you are supposed to find at the end. What is the value of A, B and C? Fine. So let's see how I can rearrange this one and you can write. So I can write this one as 2 minus 1 1 0 minus 3 4 is multiplied with a matrix A, B, C and D in order to get this matrix, which is minus 1 minus 8 1 minus 2, 9, 22. Clear? So this is how you write it here. Now you need to multiply with this thing, and if you multiply, you're gonna get another matrix which would look something similar like this. Should be 2 into A is 2A, and then minus 1 into C is minus C. Fine. This into this first row into second column, so that will give me 2B minus D, 2B minus D. Here every single multiplication or whatever you are doing here is very important, because you are all gonna give the answers or the matrices. When you start to compare it, it will come in equation, so you need to solve the equation. So in order to get the equations proper, these multiplications should be absolutely bang on. Okay, now this one, 2 into A is 2A minus 3 minus C, then 2B minus D, 1 into, now second row and first column, so A, then 0, then again like the same thing, the same second row with the second column, so B, D would become 0, then minus 3A plus 4C, then minus 3B plus 4D. So this is what I am getting, and that is equal to what? Our matrix which is onto the right hand side. Now you need to start comparing with what you have here, and thus need to get the value of A, B and C. Let's try this one. So when comparing the elements, you will be getting 2A minus C is equal to minus 1, isn't it? So 2A minus C is equal to minus 1 here. But as you see the next one, you can see A is nothing but equal to 1. So A is equal to 1 from here. A is equal to 1. So if A is equal to 1, if you substitute inside, A is 1, and when you substitute inside, it's gonna be 2 minus C is equal to minus C is equal to minus 1 minus 2, C is equal to 3. So I got the value of C here. C. Then what about D? Okay, from here I can write B is equal to, with this one, it's gonna be minus 2. And if you take this term, if you take this element with this element, so it's gonna be 2B minus D is equal to the minus 8. Thus give me, substitute the value of B inside this equation, you will get 4 minus D is equal to minus 8. Minus D is equal to minus 12. D is equal to 12. 2D minus D is equal to minus 8, right? Yeah, minus 8. Then B is equal to minus 2. This is equal to minus 2. That will give me minus 4. That will go to that side and give me, this will go that side and give me minus 4, and thus this D will be what? D is nothing but D is equal to 4. Fine. So this is what I am getting clear here. So what is now A matrix? A was A, B, C and D, which I got the values right now as A is equal to 1, B is equal to minus 2, C is equal to 3 and D is equal to 4. So this is my required matrix. Fine. Question number 7, which was from matrix, which I've asked to, if A is equal to this particular matrix, then show that A square minus 4A minus 5I is equal to 0. Hence find A inverse. Fine. So over here, it's A matrix is given. You have an equation. You need to take square over here. You need to multiply with a 4 with this matrix. Need to multiply 5 with this identity matrix. And thus when you do this particular calculation like A square minus 4A minus 5I, then you will be definitely gonna get 0. That is what you need to show first. So let's do it like a little quicker. A square, we are gonna find first A square. A square is nothing but, you know that, 1 2 2 2 1 2 2 2 1. I'm gonna multiply this one with the same matrix, isn't it? With the same matrix. Fine. When I multiply this one, what I'm gonna get here is 1, then 1 into 1 is 1, so the first row and first column, 1 into 1 1, 2 into 2 4, 2 into 2 4, that means 8 9. So first one would be 9, then the first row and the second column, 2, then 2, then 4. So 4 4 8, so that will be in this one. Then onto the third column, 2 4 and 2 again, so it will be 8. So the first one is there. Okay, fine, let's see. Then the second row with the first column will get 2 2, then 4, it will be 8. Then the second row and the second column will get 4 1, then 4, it will be 9. Then over here the second row and the column, then 4 2 2, it will be 8. Then you know the trick, then you can fill it, but still I just want to verify it. The last row with the first column, 2 4 8, this could be 8. This row with the second column, then 4 4 with 2 and 2 will give me 8, and 2 4 4 9. So this is what I'm gonna get as A square. Fine. Now let's deal with this equation, which is A square minus 4A minus 5I. Let's see whether we are gonna get 0 or not. A square, it's nothing but 9 8 8 8 9 8 8 8 9. This one minus 4A. Minus 4A is, we're gonna multiply with a 4 to this one. So when you multiply to A matrix with a 4, so it will be 4 8 8 8 4 8 8 8, it's gonna be 4. This one again need to subtract with an identity matrix into 5, which will give me 5 0 0 0 5 0 0 0 5. When I solve it, let's see what I'm gonna get here. Okay, whether it is gonna be 0 or not, let's see. What I get here is simply, okay, now 9 minus 4 is 5. 5 minus 5, 0. 8 minus 8, 0, 0. 8 minus 8, 0. 8 minus 8, 0. 9 minus 4, 5, 0. 8 minus 8, 0. 8 minus 8, 0. 8 minus 8, 0. 9 minus 4, 5 minus. So that gives me 0. That is equal to your RHS. Fine. So this was your LHS and you got to your RHS. So hence that one is shown. So hence shown. Right. So that's finished. That's done. That's very simple. Now the next one. Now here we are supposed to find A inverse from this one. Okay, let's try. This is the equation. A square minus 4A minus 5I is equal to 0, isn't it? Now always whenever any question is given to you like this and you are supposed to find A inverse from that, always make sure that your I term, take it to the other side. Why? The reason is very simple. In the next step you will get to know A square minus 4A is equal to 5I. Here what I'm gonna try to do is that now multiply the whole equation with A inverse. So thus it will be A square A inverse, fine, minus 4A inverse, that is gonna be giving me 5I A inverse. Clear? 5I A inverse. Now A square A inverse gives me A, because A, as like in the max, just think like that, man. A square into A inverse is gonna be 1 by A, right? So A 1A get cancelled, so you'll get A minus this A and A inverse will be 1, so it will be 4I is equal to, I just vanishes, multiplies, we'll get the same thing, so 5A. That means you need to find this value from this one. Just divide the entire term by 5, you will get the value of A inverse. Fine. First I need to find what is A minus 5I, 4I. A minus 4I is, A is what? A is nothing but 1, 2, 2, 2, 1, 2, 2, 2, 1. So this is my A, need to be subtracted with 4I. 4, 0, 0, 0, 4, 0, 0, 0, 4. This when subtracted, what you're getting here? It's gonna be 4. 1 minus 4 is minus 3. 2 minus 0 is 2. 2 minus 0, 2. 2 minus 0, 2. 1 minus 4, minus 3. 2 minus 0, 2. 2 minus 0, 2. 2 minus 0, 2. 1 minus 4, minus 3. So you have this matrix. So this is your A minus 4I. That means A inverse is nothing but 1 by 5 of that, and thus I will get the matrix as like this. It will be minus 3 by 5, 2 by 5, 2 by 5, 2 by 5, minus 3 by 5, 2 by 5, 2 by 5, 2 by 5, minus 3 by 5. So this one is what the matrix what is required. So this is what you are supposed to find. Fine. This is how you solve the question. Then move on to the next one then. Now in 2015, 8th question is from determinants, where it's asked Using the property of determinant, solve the following for x. So you are supposed to find the value of, solve the following for x. Okay, now you are supposed to find the value of x here. Fine. So using the property, so obviously you need to do something or the other with the rows and columns. So now when I get a question like this and when I am asked to find the solution or x value of x, I would first recommend you to just get rid of maximum x from here and you keep at most one. Okay, let's try, like, let's do a transformation. Let's see whether we could able to come up with the much more simpler way of getting the answer here. Let's see, like, so over here what I'm gonna do here is that I'm get rid of these two x's. Okay, either you can get rid of these ones or these ones at first. Actually, you have it. So C2 I'm gonna change it to C2 minus C1, and C3 I'm gonna change it to C3 minus C1. This what I will get here, I'll get something like this, I believe. So when I subtract C2 minus C1, so it's gonna be like x minus x cancels, 6 minus 2, 4, not here. This first term will be the same, first column will be the same, x plus 2, x plus 6, x minus 1, all these terms are gonna be same, and the second term is what is gonna change because we are gonna change the second column. So it will be, this one gives me 4 here, this one again subtracted with this, so it becomes x minus 1, x and x get cancelled, minus 1 minus 6, it will be minus 7 here. Then again on to this one, 2 minus minus 1, so x and x cancel, 2 minus minus 1 will be 3, yes, 3. Then when you subtract column C from column 1, so it will again minus 1 minus 2 will be minus 3. Then x and x get cancelled over here, 2 minus 6 is gonna be giving me minus 4, and this one too I'm gonna get a value 7. Fine, and it's been told that it is equal to 0. You need to carry that 0. Fine. Now here all the x vanishes. So from here also, why we need to keep all these x? Just get rid of those ones also. So what I'm gonna do, R2 gives me R2 minus R1 and R3 minus R1. Fine. Thus what I'm gonna get here is something like this. When you subtract, okay, first row is gonna be the same, then we are gonna subtract this one, so it will be 6, x and x get cancelled, 6 minus 2 will be 4 here, then 7 minus 4 will be minus 11, yeah, when you subtract it with this, minus 11, then minus 4 plus 3 give me 1, minus 4 minus plus 3 would be minus 1, yeah, minus 1. Then the last row, x minus 1 minus x minus 2, x minus, yeah, minus x minus 2, minus x and x get cancelled, minus 1 minus 2 becomes minus 3, minus 3 minus 4 is minus 1, 7 minus 3, that would be plus 10. Fine. This is what I'm getting when I am doing these two things. One I have done with the column, and here I have done with the rows. Clear? So these two things, after this one, this is where I have reached, and that too is equal to 0. Now let's get rid of some numbers from here so that I get get to see some zeros so that my calculation would be little more easier. This one, what I can write is, this one is gonna be like, what I'm gonna do here is, I'm gonna, okay, do with the columns again first. I'm gonna subtract like C2 is equal to C2 minus C3. Let's see what I'm gonna get. C2 is equal to C2 minus C3. Okay, what I'm getting here is that this row, this column continues to be the same. Okay, and this column, second column, is what gonna change it to 4 minus 3. Better add it with this. Okay, we are gonna add this. Thus we will get 1. Then when we are adding this one, it will be minus 12. These two when added up will give me 9. Right. Then minus 3, minus 1 and 10. So this is what I'm getting after doing this. Now I need to make one way or the other 0 so that I can get rid of a few other values. So more you make it 0, the better the chances of getting it more simpler way at the end. Now what I can do is that I can multiply the whole thing with a 3 and can subtract with this, isn't it? So what I'm gonna do here is, I'm gonna multiply and I'm gonna subtract a 3 from you. Okay, gonna add with this. Now, okay, I will do with this one here. What I'm gonna do next is C3. What I'm gonna do is C3 is equal to C3 plus 3 C2. Okay, fine. So C3 is gonna be C3 plus 3C2. That will give me something much more interesting. The first column is not gonna change anyway. Then the second column is also gonna be the same. Then the third one, I'm gonna multiply with this and gonna add it with this. So it thus gives me 0. And multiplying with this one with 3 gives me like 636. So it will be minus 36, right? Minus 36 plus 1 is minus 1. It's gonna be minus 37. So we are multiplying with 3 over here. Yeah, 36. Then adding with this minus 37. And multiplying with this one gives you 27. 27 plus 10 is gonna be 37. So I got something like this. Now if I am expanding through expand this one, then what I'm gonna get here is that, okay, the first term x plus 2, the first one, into this into this minus this into this. What is 37 into 12? 37 into 12, when you do it, it's gonna be 14, 1, then 6, 7, 7, 3, 4, 4, 1, 4. So it will be minus 444, yeah, minus 444, and this one would be plus 37 into 9. It's gonna be 63, and it's gonna be like 3, like Yeah, 9 threes are 27, then 33. So it will be again 333. Fine. It's 333. Then you have minus 1 into then these two numbers like 37 into 4. 37 into 4 gives you as a 28. 28 fours are 12, 14, 148 gives you, where is 148? Yeah, these two, 148, correct? 148. Then 148, these two, this one and this one, and again with now with this and this already minus and minus, so it will be plus and there is a minus already, so minus 37 into 3. So 37 into 3 gives me like 21, then 3s are 9 and 11, so 111. So 111, fine, that is equal to 0, because the last one you don't need to take because it is 0 already. Fine, so this is how you do it, which implies, so this is when you take delta or when you take the determinant value. Okay, thus now you need to simplify this one. This gives me x plus 2 into, this will give me a value minus 111, right? So minus 1111 is there, and here you need to subtract these two and multiply with 1, which when you subtract it's gonna be like 7 subtracted 1 like 3, then 0, so it's gonna be 37 is equal to 0. And from here what I'm gonna get is, okay, if you want to expand inside you can expand 111x minus 222 minus 37 is equal to 0, which gives me what, 11x is equal to these two things together, which will be 9, and this one 5, and then a 2, so 259. What is what I'm getting? It's minus 259 is what I'm getting. Fine, clear. And then if, then what is the value of x? Then x is equal to minus 259 by minus 111. Fine, here 2015 8 or question. If you are not able to do the other question, you can attend this one if you know elementary operations well. Okay, row operations or column operation is there, but it is asked to do elementary row operation. Fine here. Now this one most of the students find it like, yeah, to go for the other question because it feels a little bit confusing, but it is not there. It is not. But it's count on the steps what you write and properly. You double check it what you are doing it, and at the end I'm sure that you're gonna get the answers correctly. Fine. It may sometimes prolong a bit, okay, by getting confused, but keep a logic behind how you solve this question here. That means, okay, if a is given, okay, a is given, and I know that if I multiply like a into, okay, a inverse into a, what I'm gonna get, I know that it's gonna be I, isn't it? I matrix, identity matrix. Now what should be, okay, now in the question a inverse we will be keep on writing every single step. Okay, this is the logic what I'm making you understand. Okay, every step you will be writing a inverse. Now the thing what you will do is that a is the matrix what is given in the question, isn't it? It's given in the question, and what I'm supposed to do here is I am gonna supposed to write I also along with it, I matrix, and try to convert this A matrix into I by in such a way that multiplying, subtracting like adding with all the other rows, because it is given row operation, you need to do it with the rows. Fine, so adjust in such a way that this will become I and this I will change to something else. And what is that something else? Is nothing but your A inverse, because A inverse I is nothing but A inverse. So what you are getting ultimately over here in the matrix is nothing but your A inverse. This is another method of finding A inverse. I think it's pretty much logic is clear. So you are finding A inverse, like you are finding A inverse with the help of this. Finding it with the help of this one. A inverse into A is I, you know it. Then you are substituting the value of A. Keep on changing the rows as like to make it identity matrix. Then ultimately you will come across your A inverse, what you are supposed to find. Fine. Then move on to the question. Then if you understood the logic, then fine, we will do it together. Then make sure that your paper and pen and paper is ready. Just do one by one, step by step. Okay, you try by yourself making this one identity matrix. I will also help you with that. Fine. A is given A inverse. As I have told you, A inverse into A is equal to what? I, identity matrix, and this is of 3 into 3 order. Order 3, it will be like A inverse into the first matrix. The matrix given here is 2, 0, minus 1. Okay, 5, 1, 0, 0, 1, 3. Yeah, that is equal to what? Our I, which is 0, 1, 0, 0, 1, 0, 0, 0, 1. And this I, when you choose it, it must be same order as your A. Fine. So this is what my first step is, where I think everyone is clear about what I wrote here, isn't it? This one is pretty much clear, I think. From here, I'm just moving forward. Fine. Now, what I'm gonna do here is that my intentions would be very much clear when you do these problems. First, the element you need to look at is 1 there. You want a 1 there in the identity matrix, right? So in order to get 1, simply you need to divide it by 2. So your row R1 will be now changing to what? 1 by 2 R1. So you need to divide it by a 2. So when you divide it, what is gonna be? It's gonna be something like this, I think. It's 1 A inverse, okay, multiplied with 1, we need to divide it by 0, then it's be 0 divided with b minus 1, so it's gonna be minus 1 by 2. Then the other terms like this, but I do recommend you not to write these two columns, right? No rows at the until you finish off doing it in your I matrix, because if you forget one step, then it's gonna be it's gonna be like a big hell lot of a problem at the end if you skip one step. So make sure that simultaneously when you do here, you also get to change the values over here also. So you are also supposed to divide this particular row with 1 by 2. So this one gonna be 1 by 2, then 0 is 0, then this one is 0, then all the other rows are gonna be the same. Fine dear. So this is done now. Now what else now? Now I'm supposed to change the next one, this one. I'm gonna change this one to 1, not 1, 0, because identity matrix 1 and below it is 0. So over there, if I do it, what I'm gonna do here is R2, I can change it as 5, okay, R2 minus 5R1, isn't it? R2 minus 5R1. Then if I do, then what I'm getting here is something like this, I believe. It should be this is R2 minus 1 is gonna be like, okay, the first row, nothing is gonna change. This one is not changing, at least for now. Okay, it's not changing. The next one, this one multiplied with a 5, then subtracting it, then this will be 0. That's why we did this step, in order to make this one 0. Find here. Then multiplying a 5 over here and subtracting, it will again give you 1. Then over here multiplied with a 5 gives you minus 5 by 2. Then actually you are subtracting it, so minus of minus 5 by 2, which will be 5 by 2. Same over here, you need to subtract. You have multiplied the first row with 5, so this term will be, this element will be 5 by 2. In fact it will be minus 5 by 2, because 0 minus this term, right, r2 minus 5 into r1, so it will be minus 5 by 2. And this will be like, again multiplying over here, 5 is not possible, so it will be the same as what it is, 0 0 1. Clear? So I hope like this step is very much clear, I think. Now on to the next one. So this one is done. Now from here, okay, now the third one, fine, okay. Now let me see, like, okay, it is 0 itself, right? Okay, we will do in the next step then. This one is gonna be 0 1 and 3. Let it be like that, with 3. Now over here, this is 1 0 0 1. It's okay, quite a bit beautiful. Now this one need to be made 0 again. If you make 0, this one, I need to subtract this one with this. When you subtract it, it's gonna be 0. Fine, dear. If you subtract C, okay, now I will write it. C, no, not C, because it's row transformation. R3 is gonna be right now R3 minus R2. When I subtract this one, what I'm gonna get here? And I'm gonna get something similar to this, what I'm writing. I think the first row, okay, now these things I don't need to touch. 1 0 minus 1 by 2, then 0 1, then 5 by 2. Then here I need to subtract it from, yes, so when you subtract, it's gonna be 0 1 minus 0 1 is gonna be 0, then 3 minus 5 by 2. So if you know it, you can do it. 3 minus 5 by 2 is gonna be 1 by, but okay, now 3 minus 5 by 2, which will give me, okay, you cannot see maybe, okay, 6 minus 5 is gonna be 1 by 2, so it will be over here 1 by 2. So this one minus 5 by 2, 5 by 2. So over here also you need to do the same thing. Okay, what I'm gonna get here is again the same thing over here with rows, and with these elements is gonna change. It's gonna change it to this one multiplied with, not multiplied with a 5, then subtracted, right? No, I'm gonna subtract from here, yeah. So it's gonna be like 0 itself. uh, no, when you subtract over here, now this one is gonna be 5 by 2, this one 0 minus minus 5 by 2, it's gonna be plus 5 by 2, fine. Then 0 minus 1, it's gonna be minus 1. 1 minus 0 is 1 over here, so this is what I'm getting. Clear? I think it's pretty much clear, I think. Fine. Now in order to get rid of, okay, now all these terms are good to be an identity matrix. Now on to these 3 terms here. Now over here I could see that there is a 1 by 2, right? How to get rid of 1 by 2 is that multiply the whole thing by 2. Multiply, like what I will do, R3, what I am trying to do here is R3, it's going to be multiplied to R3. When I multiply, it's gonna be, okay, here is an A inverse already there, and this is equal to A inverse, which I left it somewhere behind, which is equal to A inverse. And when you have, okay, when you want to get rid of this 1 by 2, what I'm gonna do, I'm just gonna multiply the entire row with 2. So 0 0, and here when you multiply with 2 it's gonna be 1. So at the same time you need to do to the identity matrix also, which is now changing into something else which I have told you, right? And these terms are gonna be similar. 5 by 2, okay, cool, it's gonna be the same. Here multiplying with a 2 it will give you 5 minus 2 and minus 2, isn't it here? So this is what I'm gonna get ultimately over here right now. Then, so now this part is done, very much clear. Now over here what I need to do now, if I want to get rid of this one, I just need to do something with these terms, something like, okay, I'll write it here. Can I do R1? Okay, R1 is gonna be, okay, R1 is gonna be R1 plus, I'm gonna multiply a half with R3. I'm gonna write this term, okay, half. So that will be vanishing because it will become half. Okay, this will become half, and this half and this one when added up together, this will give me 0. Fine. And in this way, over here to get rid of your 5 by 2 as 0, you need to do R2 will now change to what? R2 minus, okay, R2 minus, okay, ultimately you need to do 5 by 2 itself to R3, and then you need to subtract it. Yes. So now first I'm doing this one, which implies A inverse and this side. Okay, now R1 is gonna change and I'm gonna multiply half. All these things will be 0 itself, only this one will become half, and I'm gonna add with this. So it will be 1, 0 and 0. Clear, I think. It's gonna be 0. Clear. So this is done. Now again and a half, okay, over here for the second one then. Okay, and please do this side also here, okay, at the same time. So I'm gonna multiply a 1 by 2 here, and I'm gonna add it with this first one. So when I multiplied half, this will be 5 by 2. So it will be 5 by 2, 5 by 2, gonna adding with this, okay, 5 by 2 plus R1. R1 is another 5 by 2, which is gonna be 6 by 2, which is 3. So over here it is 3. Fine. So I got a 3 there. Then again this one by 2, yeah, by 2, it will be minus 1. So that minus will be added with that, will give you again minus 1. So it will be minus 1 here. Again 1, which will go up and gives me 1 there. Yeah. Then to the next row, what I try to do here, I'm gonna add this R2, this row, complete R2. You're gonna subtract with 5 by 2, minus 5 by 2. So all these things will be like these two will be 0 itself, and here it will be 5 by 2. So that means the whole term, okay, now this whole term gives me, okay, this one, right? Okay, subtracting it, 0, 1, and this one when you subtract it, it's gonna be 0. While I'm doing this one, this is where most of the students get confused here, and just take some time, just think over it and do it. Like once you have start off with the problem, anyway you need to finish off, otherwise it's a waste of time. So that's why make sure that you finish off quickly as well as very carefully. Now R2 minus, if you don't know, write the steps. I am not writing too much, but you can write on a side like what is R2. Okay, R2 is like this one, okay, subtracted by this one. So over here R2 is minus 5 by 2, okay, that is R2, minus this one, this minus 5 by 2, subtract it with minus 25. So it's gonna be like minus 25 by 2 That will give me 30 by 2, so it's gonna be minus 15. So this one will be minus 15. If you check it, you will get it. And these ones are gonna be like, again, like 5 by 5 is gonna be 10 by 2, and when you subtract it, it's gonna be 8 by 2, 4. Yeah, 4 by 2. When you add it, it's gonna be 12. So it's gonna be minus, okay, I will check it once. R2 is nothing but, it's gonna be, R2 is 1 minus, which is already minus there, that's why plus by 2. So it's gonna be like 12 by 6, so it's gonna be 6. Then all the way down here, 5 by 2, okay, 5 by 2 here, that 2 and 2 get cancelled, minus 5 here, and that one subtracted with this one and get minus 5, isn't it? This one, 0, yeah, minus 5 by 2, clear. Then all the way down here, what I'm getting here, so the other terms are gonna be as same as what it is, 5 minus 2 and 2, clear. So this is how we do the elementary row operations. So we have completely done with the rows. Fine. Now what you can see here, 0 0 1, because I haven't changed it, I, so A inverse I is equal to this matrix. That means it's the value of I what I am getting, right? So A inverse, so that means A inverse is nothing but 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. This is what I'm getting ultimately as A inverse. So this is what we are asked to find, this matrix, this particular matrix, right? That is A inverse. Clear? This is what your elementary row operation is. Fine. In 2014-19, using properties of determinant, proved that 1 plus A 1 1 1 1 plus B 1 1 1 1 plus C is equal to ABC plus BC plus CA plus AB. So this is what you need to prove. Fine, I'll take the determinant here. So what is the determinant? It's 1 plus A 1 1 1 1 plus B 1 1 1 1 plus C. Fine, and this is what my determinant is, and what you are supposed to do is that you are supposed to find this particular thing. Just look into those terms, and in these type of problems you get to see that there is a diagonal elements, and you get to see the other side is equal. Now this will be like almost these type of problems you could able to see that now the other side of these elements, or other side of the diagonal matrix, now this element is equal to this equal to this equal to this, like that way the determinants are given mostly. If you check, you will get the same thing. Now in this matrix, how to form this? If I add everything, then I don't think you will get it by column or by row. If I do it, I don't think it will be like 3 plus A, 3 plus B, 3 plus C, and with that I'm not gonna reach anywhere. Fine, so okay. Now on this one, I need to get ABC, right? So what I'm gonna do is that from the first column, okay, I'm just gonna make you like this. From this column, I'm gonna take an A outside. A, what for I will tell you. From this, I'm gonna take a B outside. And from here, I'm gonna take C outside. So A, B, C went out, right? So I could able to get this particular term, isn't it? A, B, C, I got it here. I think that like that is clear. If I take A from here, what these elements are gonna be? Isn't be like this, 1 by A plus 1, the first one, because 1 by A, when A is multiplied into this one, A and A get cancelled, and this will be 1 plus A back again. So it will be 1 by A plus 1, and this, okay, this complete column I'm gonna take, I took A outside. So these elements are gonna be 1 by A, and again this is gonna be 1 by A. Fine. So that is done now. From the second column, it is gonna be taking B outside, so it will be 1 by B, and over here it will be like again as same as over here, 1 by B plus 1. Fine. Then over here it will be 1 by B. And from this column, if I'm taking C outside, it's gonna be 1 by C, 1 by C, and this one is gonna be 1 by C plus 1. I think this is pretty much clear. I think now I got a term also. Now if we used to get these type of terms, then we feel like little happier about, okay, I'm coming a bit closer to the answer. So that is what the feeling is when you do these type of problems. So once you reach here, now can I do anything else like apart from now almost like I what I would have tried the other way is that by making these two things zero. That is what people normally used to do, right? Making these two zero, but in fact like I can subtract this from this, and I can write like this one becomes zero, and that is what not that much use. That's why I took A from this first column, B from the second, and the C from the third column. Now in this type of problem you must be very particular about what you are doing and what for you are doing. Fine. Okay. Now what I'm gonna do is that if you check, can I add these row together? That means not row. I can write, can I add C1? I'm gonna do C1 is gonna be C1 plus C2 plus C3. If I do, what I'm gonna get here, A, B, C already there, and what I'm coming across if I adding all these elements together is 1 by A is there, 1 by B will be coming, and 1 by C plus 1, and this term will keep me the same term, isn't it? Look very carefully what we have done. Now this one are the first elements of the first column. Okay, first, second, third elements of the first column. 1 by A plus 1 by B plus 1 by C plus 1. So I got these terms, first term and second term, and the third term is remains the same. That gonna be 1 by B, 1 by B, 1 by C, then 1 by B plus 1. This is gonna be 1 by C. This is again gonna be 1 by B, 1 by C plus 1. Clear? So this is where I'm standing right now, and as you can see over here, this one is common, right? So I can take it out. So what I'm gonna get here, I'm gonna get an ABC already we found out, that is already there, and I took outside something like this, 1 by B plus 1 by B plus 1 by C plus 1 is there, that will be coming out, and this determinant right now will be 1 in all the first column. Then you have 1 by B, 1 by C, 1 by B plus 1, 1 by C. Clear? The other one is 1 by B and 1 by C plus 1. So this is your determinant, what you are right now up to. Then now make these two 0. How? What I'm gonna do here is I'm gonna subtract. Okay, I will make R2. R2 is equal to, R2 gives me R2 minus R1. R2 minus R1. And R3 minus R1. I'm gonna subtract this with this, this with this, and then this with this, because I need to make these two elements 0. Fine. That is the way, that is the approach what you need to do in these type of problems. As I have told you here itself, you can make it 0, no problem, but it will be a little more lengthier then. So this is much more easy, and I almost get through it. If you thoroughly check it, if I multiply inside, am I gonna get the answer here? Yes. So now this determinant And when you are wedge of getting the answer dear, make sure that you are always up to the answer or not. Now is I like I need to do anything special? So like that way you need to think. Over here I don't need to do anything because the answer is over here. This one, as you check, it's almost there. You multiply inside, you can cancel it and get to the answer. But the problem here is how to get rid of this one then. Fine, let us see. That is equal to ABC, and this one is already there, which on the next step I will just change this one. Okay, then A by 1 by A plus 1 by B plus 1 by C plus 1. Yes, that is done. And with this one, with this, what I'm gonna get, the first row is gonna be the same. It's gonna be the same, right? Second one, minus 1. So this minus this gonna be 0. Here 1 by b minus plus 1 minus b minus 1 by b and 1 by b is gonna cancel, and what I will get is 1 here. This gets to 0 because 1 by c minus 1 by c is gonna be 0. Here again it's gonna be 0 because I'm doing this one, c3 minus c1, this minus this. Then over here 1 by b minus 1 by b is 0, and this one 1 by c plus 1 minus 1 by c, 1 by c, 1 by c get cancelled, it's gonna be 1. Now going through the determinant value, that means expanding across R1, what I'm gonna get, ABC, okay, that okay, I'll write it at the end, plus 1 by B plus 1 by C plus 1 is equal to this one, 1 into, you can see only 1 is there, so this determinant value, complete value is 1 because this one is gonna be 0, this is gonna be 0 again, and 1 is the only one what I'm getting over here. Fine. So now I can simply write it. When you multiply inside, A and A get cancelled, over here B and B get cancelled, so it will be BC, the first term, plus AC because B get cancelled, plus C get cancelled, so it will be AB, and for 1 you are gonna get ABC, and this one I don't need to care much. Answer. This is equal to, I can write what is given if you want the same thing like that way. If you are not satisfied with that, you can write what is given in the question. The same thing, right? CA and AB. Fine. CA plus AB. That is gonna be your RHS, and this was your LHS. So LHS, I have proved that RHS. So hence proved. Fine. So this is how you solve this 2014-19 question. Okay, let's look into the 6-mark question. So we'll be looking from 2019 sample question paper as we have discussed earlier. So 24th question is a matrix question where it is asked if A is equal to 3, 1, 2, 3, 2, minus 3, 2, 0, minus 1, find A inverse. You are supposed to find A inverse and then solve the equation. Fine. So these type of questions is very prominent in 6-mark question. Look very carefully, and most of the questions you could able to see that this matrix would be equal to this equation, and from where you may form a matrix. But some case it might not be. It might be a bit tricky. As okay, as we look into the question, you will get an idea like what all changes would be coming in these type of questions. Fine. Let's be very sure of like these questions here, because as you know that matrix 13 marks, 1 mark surely will be coming from this portion. So make sure that you practice it well, you know it well. Okay, now over here, first in order to find A inverse, first you need to check the determinant of A first, isn't it? When you check, it is gonna be like these two elements together, minus 2 into 2 is gonna be like minus 6, yeah, then and then it is 0. For this minus 1, because its polarity is minus, so minus 1, now that need to be multiplied with 3 minus 3 plus 6, so 3, so it will be minus 3. Okay, then with this one 0, then minus 4 into 2 is minus 8. Thus when you add these, what you are gonna get? Minus 17, which is not equal to 0, therefore A inverse exists. Fine, so now you need to find what is A inverse. Now how to find A inverse? A inverse is nothing but you are supposed to find first the cofactor matrix of A first. You will be finding the cofactor first. How to find the cofactor is just leave that element or take that element and hide that column and row and take the other element and then do the determinant value, do the value for those. If I'm looking at 3, then 3 into, not 3 into, leaving that column as well as the row, then these 4 elements, when I check it, it's gonna be minus 2. So minus 2, because this one is gonna be 0. So this is positive polarity, so the sign remains the same. Fine. Then over here, it's gonna be like minus 3 plus 6. So 3, and the polarity changes over here, so it will be minus 3. In this case, it's gonna be 0 and minus 4, and the same polarity minus 4, it's not gonna change. And in this place, like minus 1, yeah, minus 1, and here it changes, so it will be 1. It will be 1, yes. And here it is positive polarity, so positive, negative, positive, negative, positive, negative, and positive, negative, positive. So it will be like that. Okay. So over here, 2, how you could able to write it? 2, leaving this particular column and this row, you will get to see 3 into 1 minus 1 is minus 3, so it's gonna be minus 3 and then over here, sorry, it's gonna be minus 4, so minus 7, and it's positive, so it will be minus 7 itself. Then on to this element, we are hiding this particular column and row. I'll get to see these elements, 0, minus 2, so that will be changing the polarity to 2. Then all the way down here, so these are the elements you need to check. Minus 3, minus 4, minus 3, minus 4 will be minus 7, right? Fine, minus 7. Then for 0, it will be like this column and this row should need to hide, and these elements like minus 9, minus 6, minus 9, minus 6 is gonna be minus 15, but polarity is different, so it's gonna be 15. So 1, 5, 15. Thus the last one over here, I hope like there is no mistake, I think. Yeah, 9, minus 9, minus 6, yes, because you need to be, now this matrix is the place where you double check, it's not a problem, but if you make a mistake, the other step or the next step is gonna be completely wrong. So you need to be very sure about what you are writing. Even if you check it once or twice, if you can, like very quick way, you check it, it's good for you. For this term, it's gonna be like 6 minus 3 is gonna be 6, 3 itself, so positive polarity, so 3 it is. Now what you need to find here is adj. Adj is nothing but transpose of cofactor. What is your cofactor matrix? That matrix transform. You need to transform it, so the rows becomes columns. So minus 2, 1, minus 7, minus 3, minus 7, 15, minus 4, 2, 3, and from there, how to find A inverse? A inverse is nothing but 1 by into adj, that's equal to minus 1 by 17 is what my my determinant A. Then 1 minus 1 by 17, minus 2, 1 minus 7, minus 3, minus 15, minus 7, 15, minus 4, 3, 2. This is what I'm having for A inverse. So A inverse is nothing but this particular matrix. Fine. Then now you are supposed to find from this equation x, y, z. Fine. Now from this equation you can see that it's going to be 3, 3, 2, 1, 2, 0, 2, minus 3, minus 1, which is gonna give me x, y and z, and get me this value 1, 4 and 5. Fine, this is a, x and b, as you all know. Yeah, now equal to sign, fine. Now when you compare with A and this one, you could able to see that there is a small slight change. That is what I was talking about with this and this, isn't it? So this I could able to clearly see that there is a transpose of this A over here, isn't it? So I can write this is nothing but, okay, usually used to write A x is equal to B, right? Now this is nothing but it is A transpose. This is A transpose from there. So in that case, what is going to be the x? So x is going to be nothing but A transpose inverse B. Fine. And which in turn you can also see in this way. This could also be written as x is equal to A inverse transpose B. That means you need to take the inverse transform and multiply with B, thus you get your value of x. Fine, that too also could be done. So in that case, that is pretty much easy. So how to find it? Now what you're gonna do is I'm gonna make that matrix, which I'm gonna make it transpose. A inverse transpose I'm gonna make. Thus I will get you minus 2, minus 3, minus 4, 1, minus 7, 2, minus 7, 15 and 3. So this matrix I have it here. Then you're gonna multiply this one with the other matrix, which is my B. This is your B, this is your X, this is your A actually. Fine. And this is gonna be 1, 4 and 5. When you multiply, what I'm gonna get here, minus 1, okay, I will write it here, 1 minus 2 into 1 is minus 2, minus 3 into 4 is minus 12, minus 4 into 5 is minus 20. So thus gives me a value 32, 34. So it is minus 34. Yeah, minus 34. And over here, what I have 1, then minus 7 into 4, it's gonna be minus 28, 21, 28. Then 2 into 5 is 10. So thus like minus 18, and minus 17. So this is gonna be minus 17. Then on to the next one, minus 7, then 15 into 4, 15 twos are 30, then 4s are 60, 60, then 5 into 3 into 5 is 15. So subtract 7 from 15, what you will get? You get 8. So thus gives me 68. Fine here. And thus from here, one thing what I left out, which I want to add is that, and you don't need to miss it, and I really missed it over here, which you don't need to forget to put it, that is this determinant value minus 1 by 17, and that too will be coming all the way down here, minus 1 by 17, and which when you divide, that matrix would be in this fashion. It will be in, when divided by 34 two times, it will be minus, and minus will get cancelled, it will be 2 plus 2, and over here also minus and minus will get cancelled, 17 will go, it will be 1, and 17 7 into what is 68, 7 into 4 is 17 into 4 is 28, right? 17 into 4 is 28, 28 like first one, and 4 8, like 4 6 68, so it's gonna be 4, so minus 4. So these are my x, y, z value. So x here is 2, y here is 1, and z is minus 4. So these are my values which I got it by solving my equation. So 2, 1 and minus 4. Fine, dear. So this is how you solve your A inverse, and this is how to find A inverse as well as solve the equation. Fine, we'll do one or two questions. We are so if you guys are confused here and there, you will get a clear idea as it goes. So this was the question, so it's pretty much easy, so you can do this one, right? This is the 2019 sample question paper, 24th R question. Find the inverse of the following matrix using elementary transformation. So elementary transformation, you need to do it, and with that you need to find what? A inverse. Now finding A inverse, first of all, I would like to tell you is that the concept behind this one, I used to explain every single time to my students that you have a matrix given, this is the given matrix, right? And that we call it as A and all, and you know that, okay, you have another, or A into A inverse, the A matrix, the matrix A into its inverse, that you know that it's going to be I. That means identity matrix I, isn't it? Fine. In that way, as you keep on going, this, the given matrix, what I need to do is that I need to change that one into identity matrix. I need to try to change my given into identity matrix, so that the what all changes we are making here, the same changes you need to make it here, and thus no more would be identity matrix, it will be something else. What that something else, and your A inverse, we won't be changing anything, we will be just writing A inverse itself, and at the end what I'm getting is I into A inverse is A inverse itself, and what you are coming across over here is what your answer is. Fine. And then other I have seen that some of the teachers used to show that this is also correct, like A is given here, okay, A is given, and that you know that A is equal to nothing but AI, right? Isn't it? And okay, you used to write I and A there. Then you keep on doing it, you change the identity matrix into what? Into, this is a given matrix, that one is given, that you are changing to something else by changing, making this one into identity matrix, so this particular thing will be changed to something else. You still have A, then at the end you used to write hence A inverse is equal to this particular matrix. Like that way also it could be done. Okay, fine. So we will be start to do with anyone. It's fully up to you. Fine. Both the concepts are same. It's just the steps what you need to follow should be correct, and need to get to the required, that this one need to be converted to the identity matrix. Thus the other matrix formed will be your A inverse. Fine. So move on to the question then. I have here something like this right now. Normally what you are supposed to do, we are supposed to make the first term of the matrix to 1, because identity matrix, as you know that this I am converting to identity matrix. So I will be doing in this way. You know that A into A inverse is nothing but what? Identity matrix, right? So that means this matrix, what you have here, 2 minus 1 3, minus 5 3 1, minus 3 2 3, that matrix, what I'm gonna do is that when it is multiplied with A inverse of this one, I'll be getting I. It's a 3 by 3 matrix, so I will write an identity matrix of order 3. Yes. Now, as I have told you before, concept is to make this one an identity matrix. So the changes what happen will give you that, and at the end your A. Fine. Let's start it. How to make, okay, this is what really we wanted. This is what we need to keep it important. The next one, what I'm gonna do here is that to make it 1, can't I do like this R1? What I'm doing is R1 plus R3. If I do so, will I get something like this? This when added up, it will be minus 1. Okay, it will be fine, it's okay. It's gonna be minus 1. Then this is gonna be like when you okay, when you add it up, right? Yeah, minus 1. Then when you're adding up this one, it's gonna be 1. And here you're gonna get 6. And I used to make sure that while I'm doing this side, I also tend to do this side. So I won't skip any step. So it will be good that simultaneously you do it. I normally like used to do it. Sometimes I used to skip it, but need to remember that what you're doing here, that entire step, you need to do it at the same time over here too. If you skip one, the answer is gonna be wrong then. So you're gonna add this one, it gives me 1. When you add up with this, will give you 0, and this one I'm gonna get a 1 here. Then rest of the term is gonna be the same. Correct. Fine. So got this one. What I will do is that I'll just multiply the whole thing by minus 1 then. Okay, I'll write it like 1 minus 1. This is gonna be minus 6. Fine. And over here it will be when you multiply with minus, that means over here what I did R1 minus 1 R1. Fine, I did so. So thus I got this one. Then the elements is gonna be the same as before. Fine, it's clear. I've told you why we are doing it, right? Because we need to make this one 1. I want to convert these two as 0, or these two elements I need to change it to 0. In that case, what I will do here is that I will do R2 is gonna be R2 plus 5 R1. I'm gonna add it with, because this is already minus, and R3 I'm gonna change it to R3 plus 3 R1. Thus what I'm gonna get here, I'm gonna get multiplied by 5. Okay, if you're not so sure of, just write to your side and just do it, no problem. And this is what our steps, what we are doing it till now. Now this one, okay, R2 is what gonna change, right? Fine. So the first element is gonna be the same. This is same. A inverse is already there. That is equal to this one. Again is gonna be the same. It's pretty much same. Then the next terms, this one 0. Multiply with a 5 and adding with this, so it gives me minus 5. 3 minus 5 is minus 2. This will be minus 2. With 5 gives me minus 30. Adding with this one gives me minus 29. For this one, multiplying, okay, now here this side, multiplying with 5 and adding it, so it gives me minus 5 here. And 1 minus, okay, now adding with multiply, okay, now the same thing, 1 minus 5 then adding it, so it will be minus 5 itself, minus 5. Then with the last one, with the 3 I am multiplying with this and adding it, so it will be clearly 0. 3 minus 3 and adding it will be minus 1. Then this one multiplying with a 3, that gives me a minus 18, and adding this will give me minus 15. Minus 15. Here multiplying with 3, then this I will give me minus 3, 0 and minus 3. And adding with this one will give me slightly bit different. That is like multiplying this one and then subtracting. Okay, fine. This one is 3 minus 3, 1 minus 3 is gonna be minus 2. It's gonna be minus 2. Clear? So that is done now. Fine. Now once this is done, now what is the next step then? So we have done all these. Now these two things we made it 0. Now one thing, I don't take this one, I will just interchange it here, because already there is a minus 1 here, so I can make it minus 1 by just by subtracting with this one. Then again, yeah, 1, that was true. Fine. What I'm doing here is, okay, what I told you at the end, I'm gonna interchange this one. I'm gonna interchange these two, so it will become minus 1, and also I'm gonna change here R2 to R3, and then R2, what I'm gonna do when interchanged, after that I'm gonna change, because there is a minus 1 there, so it will be multiplied with a 1. Okay, let's see like what with this changes, how our matrix will look like. First row, no, it's gonna be same. It's gonna be, now this one got interchanged and will change the sign, so 0 1 and it will be 15. Yeah, the other one will be coming exactly as same. Okay, and thus the changes must need to be applied over here also. So the first row would be the same, the second one I have interchanged and changed the sign, so 3 0 and 2. The other term will be, the interchanged row will be as same as it is. Fine. So I got it till here. Now it's the time for me to make the second one 0, or this one 0. Fine. Okay, I can also convert this one. I can also make 0 over here also, right? So for that, what I'm gonna do here is, I'm gonna do two steps together. Okay, R1. Okay, R1 is gonna be, because already there is 0 here. Okay, it will be R1 is equal to R1 plus R2. Yeah, R1 plus R2, and R3 I need to change it, because this place I want to make it 0. So R3 plus 2 times R2, isn't it? Multiply this one with 2 and then subtract it. Now add it, because already there is a minus sign. So thus I will get here something like this. Now what I have here, these terms, then from here, first term, adding it with these. So first one I don't need to, okay, I'm gonna change it. So 1, because this is about first row. So 1, these one added up will be 0. When added up will give me 9. This will be 9. And the second row is not gonna be changing. As of now, it will be as same as it is. Then this will be like R3 is equal to R3 plus 2R2. So this one remains the same. This one with 2, adding up will give 0. Multiplying with 2 will give you 30. And when you adding minus 29 with 30, I'm gonna get 1 here. So it's 1. And that is it. A inverse equal to, what I'm gonna get here. So you got an exact idea, right, how we reached here. Now these ones, the same thing. Yeah, I should have done it. In fact, no problem. R1 plus R2 you're gonna add these two together for R1. This it will be 2. Yeah, these ones are gonna give me 0 itself. When added up together, it will be 1. Then for this term, I'm not gonna change, so it will remain the same. For here, multiplying with 2 here, I'm gonna add it with this. So multiplying with a 2 and adding with this. So multiplying with 2, 6. Adding it will give me 1. And multiplying and adding will give me 1. Then with 2, with 4, 1 adding it will get me minus 1. So this is where I reached so far. Fine. This is where we reached. Now, our intentions are very clear. These two need to be made 0. Fine. So it's a pretty lengthy one, this elimination method, the transformation method. Okay, fine. So how to make this one 0? And moreover, you need to think step by step here. Make sure that these two things are made 0, then try to make this one. So like go like this, then make it like go like this, make it 0, 0. Then try to make this one 1, then come down and make it 0. Like that way, step by step you can do it. Then make this one 1. Yeah, like that way it is good to do step by step in this one here. You will get for sure. Once like when you start doing it, and those who are doing it for the very first time will feel it like, do I need to sit for a much longer time to get this answer? Yes, you need to, but surely you get a proper answer if you are doing it correctly. If you are believing, or if you are taking it step by step, you will get it there. Make this one 0, again this one, then try to convert this one into 1 first of all, this one 1, then this 0. Like that way, step by step you do it, and so the same changes over here, you will get it properly. Now, simply you can just do 2 more steps to get the answer here. To make it 1, what I need, 0, what I need to do? Definitely R1 I need to change it. R1 should need to be R1 minus 0 here, right? Okay, 9 R3, and to get that 15 0, R2 should need to be changed to R2 plus this one is gonna be 15, right? R2 minus 15 R3. Fine. Thus, what I am getting here, the matrix here with the first element becoming 0, because this one like multiplying with 9 doesn't work here. Okay, at the same time I just want to do it with this one too. So what I'm gonna do, okay, this one with this R1 I'm gonna subtract. What is R1? This one, right? I'm gonna subtract 9 into this one. So 9, when I multiply with this R3, it's gonna be 9 minus 9. You're gonna subtract it. So when I subtract it, this gonna be minus 9. When you subtract this one, gonna be giving me minus 9, minus 7 minus 9, and this will be 1 minus 9. So 1 plus 9, 1 plus 10, no, 1 plus 9, it's gonna be 10. Fine. This is what I'm up to right now when I did this. Now over here it will be, you don't need to very much because it's gonna be the same matrix, identity matrix, what you are coming across, because 15 and then subtracting it will be 0. Over here I'm gonna multiply. Okay, now what are the number? 302, and I'm gonna multiply a 15 over here, so it will be 15, 15 and minus 15. Fine. So when you subtract it, 3 minus 15 minus 12, 0 minus 15 minus 15, 12 minus 15, so it will be 17. So that's done. Then again the next row is gonna be the same. Fine. And where we reached, so that's why this becomes I, so I don't need to write I here. A inverse is nothing but the value over here. This is what you are looking forward for. This is the matrix with the elementary transformation here. You got A inverse. Fine. Then chalo, let's move on to the next question then. In 2018, 29 question was from matrix where A is equal to 2 minus 3 5, 3 2 minus 4, 1 1 minus 2. Then find A inverse, use it to solve the system of equations. Okay, equations. What are the equations? These are the set of equations 1, 2 and 3. Fine. Now anyway it is asked to find A inverse first. So first we will do that. For finding A inverse, I have been keep on telling you that first whether you need to check whether A inverse exists or not. For that you need to take the determinant of A. Determinant of A is nothing but 2 into, as you know, like 2, the first element into these two. This one gives me minus 4 and these ones gives me plus 4, and thus it becomes into 0. Minus 3, that become plus 3 into the terms here, which is minus 6 plus 4 is gonna be minus 2, because minus 6 plus 4 is minus 2. Then plus 5 here into what is gonna be these two numbers. So 3 minus 2 is gonna be 1. So over here what you get ultimately is what you're getting here, that is gonna be 0 this term, this is gonna be minus 6 and 5. So minus 6 plus 5 is minus 1, which is not equal to 0. So A inverse exists. Fine. So this must be your first step when you are finding A inverse. Fine, dear. And after that, then you need to start thinking about how to make A inverse. And I have been keep on telling you A inverse. First you need to find the cofactor matrix of, then you need to find the adj, then A inverse is equal to adj by determinant A. This is what the steps need to be there to find A inverse. Fine. So moving on to the first step, what I have told you, you need to supposed to find what? Cofactor of A. So cofactor matrix is what you're gonna find first. So cofactor is gonna be, in this element cofactor is these, which with the polarity you need to, now this one is positive, so this one anyway I was getting 0, so this is 0. Over to this element, this was minus, and minus 2 is gonna be minus 6, then plus 4 is anyway minus 2, with the polarity negative it will be plus 2 here. Fine. Then about the 5, now 3 minus 2 is 1, which is positive polarity there, so I don't want to change the sign. Then now with this term, this is gonna be 6 minus 5 1 with a negative polarity, because plus minus plus minus plus minus plus minus plus it will be. Then 2, these two gives me minus 4 and these ones gives me minus 5. So minus 4 minus 5 is minus 9 and it's positive, so it will be minus 9 itself. Then minus 4, these terms are what I need to look at. So 2 plus 3, it's gonna be 5, but a negative polarity here. Then over to this particular element, it's gonna be these terms, so it's gonna be like 12 minus 10, it's 2 with a positive 2, right? So these two minus like 12, that minus 2 minus 10 is 2. Then for 1, these elements, 2 into minus 4 is minus 8, minus 8 minus 15 is gonna be like, anyway it is minus 8 and minus 15, so you need to add it, so it's gonna be minus 23. So it's minus 23, but the polarity here is minus, so it will be plus. Then minus 2 is here, so for these terms 4 plus 9, 4 plus 9 is nothing but 13 with positive polarity, so with plus. Fine. So 4 and 9, then it's gonna be 13. Fine. Now in these type of in metrics dear, why students a lot spend a lot of time on this one was like basically they look forward for whether I have made a mistake or not. It's obviously good at one point of time that check it once that whether what you have wrote is correct or is proper or not. If not, you can change it there instead of like doing everything and then finding it like okay you have done something wrong, so better than that, that is good, fine. So this is how you do it. And then after this one, what I'm gonna find is you have told you you need to find what aj here. Aj is nothing but another matrix which is transpose of cofactor matrix, which is a transpose of the cofactor matrix, and that is gonna be what columns becomes rows or rows becomes column, that is transpose. So I just transpose this matrix. And now for finding A inverse, it's what I have told you, adj by okay, adj of adjacent by of A by determinant of A, that's gonna be -1 is what I got it from here, right? -1. So I'm gonna multiply this complete term with a minus and I'm gonna write it. So it's gonna be like 0 here. So anyway, like I'm not writing that step of 1 by -1 and all those stuff. I'm gonna multiply inside. So it will be 1 0 1 -2 -2 9 -23 1 okay -1 +5 and -13. So this is my A inverse. So I got my A inverse right now. How to use it to solve the equation? Let's see. As I was like previously we have done some similar questions like this where I have told you that when you write your x, y, z term, sometimes you might feel like it is not same as A. It might be A transpose. Then you need to take the A transpose and need to do it. Over here, let's check how it has been given. First element 2, then -3, then 5. Over here I have 3, then 2, then I have a -4 here, right? -4, 3, 2, -4, 2, -3, 5, yes. And over here I have 1, 1, and then -2. And this is my matrix which I check. It's gonna be almost similar. It is gonna be same as A. So I can use this one as matrix A, right? And as per the equation given, I can set this matrix in this form. This into x, y, z, as you know that this is matrix X. And when you multiply this, what you're gonna get here, you're gonna get this matrix having these values, which is onto the right hand side of the equal to sign. So it's gonna be 11, -5, and -3 are these three results what is gonna get at the end when you multiply these things. Fine. Now, so this is gonna be B. So as you know that Ax is equal to B, how to find the value of x? It's nothing but A taking to that side, or you can just simply believe it like A inverse, like you are taking A inverse on all the sides. A inverse becomes I, which I don't need to write. So here it becomes A inverse B. Fine. So that means to say that when you have A inverse here, you just multiply with the B matrix, you will get to find what is the value of x, or what is that x matrix. Fine. Then you would able to get what is the value of x, y, and z. Fine. Now here, as per this one, what I can write, it will be A inverse. So A inverse, I already knew it, which is I already have got the answer, which is 0, 1, -2, -2, 9, and -23, -1, 5, -13. That should need to be multiplied with 11, -5, and -3. So this is how you're gonna go with finding the x matrix. Find here. Then now the first row with this column. So what I'm gonna get here, okay fine, I will write the answer here. Okay, what I'm gonna get. So now 0 into 11 is 0, 1 into minus 5 is gonna be minus 5, minus 2 into minus 2 into minus 3 is plus 6, so that one will be 1. Yeah, first term is 1, first element is 1. Then minus 22, which is minus 2 into 11. Then 9 into 5 gives me another 45. Yeah, minus 45. Then 23 into 3. So that means plus, this is gonna be like 6, no 9, then 6. So it's gonna be 69. When I add these two 20 together, it will be 65, 67. Then my subtract it, it will give me a value 2. You can check it. Okay, check like this. You will get 2. And I have told you, like, keep a paper with you. Make sure that while I'm doing it, make sure that you do it. If you know it, just try to do it once. Try looking at the answer whether it is correct or not. Find it. Then the last row, minus 1 into 11 is gonna give me minus 11. 5 into minus 5 is minus 25, and over here I will get plus 39. And here if I plus it, it's gonna be like 35 plus 1, 36, then 3 here. Yes, so I got a matrix which is 1, 2 and 3. So that means to say that x is equal to 1, y is equal to 2, z is equal to 3. Fine. So this is what the value I need to get at the end by solving it, by using this inverse. Finding the inverse and keeping it over here, I'll getting a value x equal to 1, 2 and 3. And the last problem I haven't told you about, like how to verify it. Make sure that you spend a little time, just hardly 1 minute, to just check whether it is correct or not. I will probably take one of the equations, like the first one over here. Okay, it's gonna be 2x minus 3y plus 5z. Okay, let's see like whether I am getting the right hand side, which when we apply this one, what I'm gonna get, 2 into 1 minus 3 into 2 plus 5 into 3, and I'm getting something like this, which is gonna be 2 minus 6 plus 15. And when you take out this 2 and minus 6, it's gonna be minus 4. Then you subtract, it's gonna be giving me 11. So here it is 11. So that means this is correct. So x, y, z. So make sure that you check it. Okay, check it and just be sure of these answers, because 13 marks is very much. Okay, chalo, move on to the next question then. It's a elementary row transformation method in which you need to find the inverse of matrix A 1 2 3 2 5 7 minus 2 minus 4 minus 5. So you need to find inverse of the matrix. Fine. As A is given, you know from here A into A inverse is equal to nothing but you are getting identity matrix, isn't it? You need to know this one, dear. Okay, now first of all, like for those who really don't know what is transformation and how to get to inverse or how to find inverse, you know that A into A inverse is nothing but I, right? If you have like x into x inverse is equal to 1, just the same way A into A inverse is I, identity matrix, where identity matrix you already know it is like 1 0 0. If it is like 2 by 2, it's going to be 1 0 0 1. Fine. So that is how you do it. Now here the basic concept behind this one is that you have a matrix, okay, which is that A matrix, okay, which now you will just multiply with this, and you have another matrix which is identity, which is formed by multiplying these two. Now as the step progresses, what you need to find here is A inverse, and how can I find this one is changing my A in such a way that I would get an identity matrix here. I would get an identity matrix here, and as we have making the changes, the same changes should need to do along with this identity matrix also, and that will be changed to something else right now. And thus you know that I into A inverse is nothing but A inverse, and what you are coming across, that particular matrix is gonna be A inverse. Fine. So what I have told you, I have A, which is over here, into A inverse is gonna be an identity matrix. Fine. Okay. Fine. I have this one over here. Then okay. I will write that step for you. So you have a matrix which is 1, 2, 3, 2, 5, 7, minus 2, minus 4, minus 5. So you have matrix here that need to be multiplied with a inverse. I'm not gonna change A inverse throughout because at the end I want an A inverse. Fine here. So I have an A inverse here, and then when you multiply these two, what you are ending up to, or what you are coming across, you are gonna reach to a identity matrix, and this one is an order of A, which will be 1 0 0 0 1 0 0 0 1 3 by 3 identity matrix. Fine. So can you compare this step with this? So it's almost the same. So now clearly my intention now is to make this matrix as it goes, make it to I, make it 1 0 0 0 1 0, like that fashion you need to make it. Thus the same changes, what all changes you are making here, the same changes you need to do it all the way down here, so that you get to see I here. I into A inverse is gonna give you this particular matrix, what is formed at the end. That is how you find the inverse of the matrix. Fine. What I'm gonna do here is I'm gonna make my first step would be making these two zeros. I can make it one step, no problem. What I'm gonna do here is that, think about it. Okay, what I'm doing, R2 I want to change it to 0. In order for that, I'm gonna make multiply the first one. So R2 minus, I'm gonna subtract with 2 multiplied onto the first row. So when I multiply with the 2, this becomes 2, 4 and 6, isn't it? That should need to be subtracted. When I subtract each one of the term, you could see that the first term becomes, or this term becomes 0. Okay, let's deal with the other one. Where I subtracted now with the third column, third row, you need to add it with. So R3, what I need to do, R3 plus 2R1, when you add it with R1. Let's see what I'm coming across when I do these two steps, or when I do these two steps. Okay, fine. So here is the matrix and A inverse, and you have the place for the second matrix here. Fine. So the first matrix, the first row is not gonna change because I want to keep that one there. I want it, so I'm not gonna change it. Fine. Then on to the second row, as I have discussed, into 2 I got these numbers. When you subtract 2 minus 2 is gonna be 0, 5 minus 4 is gonna be 1, and this one again will just give me 1. Fine. So that is done here. Now when you add it with this one, with these numbers, what I'm gonna get, I'm gonna get 0 here, 4 plus minus 4 plus 4 is gonna be 0 again. Then when you add this one, it's gonna be 0. If it's the case with the same thing there. Now one thing you need to be very sure about, what you have done over in this particular matrix, the same thing need to be done here. You can actually do the rows first, and then the first row first, then the second, then the third, like that way throughout, if you are confused about it. So the first row I didn't change over here, so neither I'm gonna change over here. So the second one I just multiply with the 2 and then subtract it, so only 2 will be applicable here, because the other 2 was gonna be 0. So when I subtract, it's gonna be minus 2, then the other terms are gonna be the same, because I don't have, okay, now over here, okay, into 2 and not from here, yeah, I was just searching over here. Okay, from here, so multiply with 2, then subtract it, it's gonna be minus 2, Yes, then over here these two terms it's gonna be like 0, then 1 minus that 0 is gonna be the same thing, 1, and 0 minus 0 again 0. Fine, on to the third one. Then you are multiplying with a 2 again, 2 here, and then you're gonna add it. So here it will be 2 and this will be added with, like, we'll get 0, and 1 plus 0 is again gonna be 1. So this is my matrix where I reach right now. So almost over here you could see that almost these portions are now exactly look like your identity matrix. Right now it's the time for me to adjust over here and get it with this one, get it over with these elements over here, and these elements should need to make it as 0. And how to make that one? Let's try it. Okay, let's try this one. And this one gives you and gives you, and again from here. Now what I'm supposed to do here in order to get rid of this 2, I want to make this one 0. So what I will do, if I multiply this complete term with 2 and then subtract it, what I will get? Okay, I'll write that C1 is gonna be C1 minus 2C2. What about this one? What I'm gonna get for these? Okay, from okay, when I do this step, okay, here I have this matrix, then I have the inverse and the matrix over here, my identity matrix, but it is now slowly changing into something else, which already I spoke about once. At the end it will reach A inverse. Fine. Over here when I do this step, now this one is what I'm gonna change, the first row. So 1, okay, I multiply with this one, okay, it's not gonna change anything, that will 1 remains the same. And with this one 2 multiplied, and then I'm just gonna subtract C1 minus this one is gonna give me a 0. For that reason only I did this step. Then again multiplying with 2, I'm gonna subtract this 1. Oh, sorry, here it is not C1 there, sorry, this is R1 and R1 minus R2. Okay, be sure of like what you're writing. Okay, so I made a mistake over here, it was not column, it was rows. Now then what I, okay, where are, okay, multiply with 2, I change, okay, this is 2 and this is R, okay, 2R2. So 2, and then I'm gonna subtract this R1 minus that 2, so that will give me 1 again over here, so this will be 1. Fine, that will be 1, and then the other terms are 0, 1, 1, 0, 0, 1. Fine here. And the same thing over here we need to do. We need to multiply this one by 2, right? Multiply this one by 2. That if I multiply, it's gonna be, the first one is gonna be 4, the other one is gonna be 2. Now you're gonna subtract this one. When you subtract 1 minus 4, minus of 4 becomes, this one becomes 5, because 1 minus 4. Then the second one 0 minus 2 right now, so that will be 0 minus 2 is gonna be minus 2, yeah, and this one 0, 0. Now over here what I'm getting, okay, I have, did I change anything? No, it's gonna be the same, minus 2, 1, 0, 2, 0, 1. This is what I reached, this is where I reached. Now the next step, let's see. Now it's a time for me to just get rid of these two terms, these two elements, and I need to make it as 0. So what I'm trying to do here is I'm gonna subtract, okay, this one from this. Okay, if I do from here to here, it's gonna be troubling me. Okay, fine. Now, okay, can I write R1 is gonna be R1 minus R2? If I do so, R1 minus R2. Okay, if I write it like this, there is a major issue, because if I do this one, R1 is gonna be R1 minus R2. R1 minus R2 means this will be minus 1. So this term will become minus 1. So I don't want to do such a step, because it is gonna be it's not for use anyway. So what I'm going to do is that then R1 subtracted by then R3. If I write R3, then this term subtracted by this, yes, this one. Then this one also need to be changed. That one R2 need to be changed because of this particular reason, that I want a 0 here. So R2 again with R2 minus R3 we can take, yeah. And thus what I get here is, okay, now the first one, as I have told you, R1 minus R3. So now these two are not gonna change, it's gonna be the same. Then this will change to 0 because you have subtracted it. Yeah. Then the first, okay, over here, R2, I'm gonna subtract it. So it's gonna be 0, then subtracted with the 0, again 1, and this becomes 0, 0, 0, 1. And like our identity matrix. Just be a little careful about the last step what you write, because what you have done is so far it's correct, and I don't want to make any mistake at the end. So over here what I did, R3 minus R1 minus R3, so the first one, R1 minus R3. So when you subtract it, it's gonna be 3 R2. Okay, now this one, anyway, it's gonna be 0, so it's minus 2 itself. Then over here, 0 minus 1, give me minus 1, fine. And then the second row need to be subtracted from the third one. So minus 2 minus 2 gives you minus 4. And 1 minus 0 is gonna be 1. 0 minus 1 is minus 1, and the last one 2, 0, 1. Fine. This is what we are right now up to. Fine. This is what I really wanted, because this one is what IA inverse, right? That in turn is what? This particular one. So that I don't need to write this one. This is simply AI itself. So from here I can ignore this one, I can write. So therefore A inverse is nothing but this matrix, where the values are elements are 3, minus 2, minus 1, minus 4, 1, minus 1, 2, 0, and 1. Fine. This is the matrix what you are looking forward for. Right. So this is what your answer for this question for 2018 OR question, 29th OR question. Moving on to 2017, 24th question is from matrix, where they have asked to determine the product of this matrix and this matrix and use it to solve the system of equations x minus y plus z is equal to 4, x minus 2y minus 2z is equal to 9, 2x plus y plus 3z is equal to 1. So these are the three equations given, and it's asked to solve this equation with the help of this product. Fine, dear. Now whenever I see such a question, I have a very bad habit of taking those equations first and just comparing with the terms. It's gonna be 1 minus 1, so 1 minus 1 minus 2, yes, this one, then yes. So these equations are related to this, that you need to have an idea at first itself. Okay, when you do it, make sure that you just keep that one in your mind. Okay, this is what. Now if it is said that if only this one is given and it is asked to find the A inverse and then need to solve the equation, yes, take this equation. Okay, take that equation or take some other equation and then find A inverse, and quite naturally you will get to see that the equations what is given over here, like the matrix what is given and the equations would be as similar, or it will be, there will be a slight bit difference, like once we have just done transpose of the first matrix into that formula ax is equal to b, from where we will find a inverse. Fine, so those things will come, but okay, this how to do this problem is, two metrics are there, anyone like you can pick it, and one big thing what you will, okay, I will take this as a and this was b. So what I have here is two metrics which I'm gonna take the product of it. One is minus 1 1 minus 1 1, 1 minus 2 and minus 2. Then you have 2 1 3. Okay, this is one matrix which need to be multiplied, either multiply this with this or that with this, it's gonna be okay, fine. So when you multiply these two, it's gonna be like minus 4 4 1, minus 7 1 3, 5 minus 3 minus 1. So I'm gonna get this particular value. Fine, any problem? I think it's pretty much clear, right? So this is gonna be your A matrix. This is not I'm gonna write, okay, C here, because B already I'm using it later. So AC I'm gonna multiply. So let's see like what I'm getting with AC. So AC would be nothing but rows with the column. That is how the multiplication is done in that way. What will be the value of these there? 1 into minus 4, so minus 4 there, and you have yeah, minus 4. Then 1 into minus 7 is gonna be plus 7. Then 1 into 5 is gonna be plus 5. So when you add it, okay, now these two things give me 1 and this one gives me 8. The first one is 8. Fine, any problem? 8. Then the first row with the second column, I will get 4 here, 1 with, okay, this one 4, minus 1 with 1 gives me minus 1, 1 with minus 3 gives me minus 3, thus I will get 0 here. Multiplying this one, this first row with the third column, I will get 4 and this one minus 3, then 1 minus 1, thus again I'm getting 0. Then second row with the first column, minus 4, minus 4, then I have like this minus 2 and this one gives me plus 14 and the other one gives me minus 10. So yeah, I'm getting 0 here again. The second row with the third column will get to 4, 1 with this 4 gives me 4, minus 2 with this one gives me minus 2, then minus 2 with this one give me okay, the first one with this one right there, okay, and give me plus 6. With that 2 get cancelled, then 8 again, 8 here. Fine, the next one 4, then 6 again, 2 added up 0. This row with this column, I was just like doing this one, this is how it is done here. Normally this is how you need to do it. Don't be get confused, take a side and write it, no problem if you write it and just see. Don't be always keep those one in your mind and pile up and you will get confused with that. Okay, do it to a side, no problem. Then this one should be done apart from not from the working, okay, in the working area, right? And over here when you do like minus 8, then minus 7, minus 8 minus 7, then 15, minus 7 15, then again 0. Then this third row with the second column will give you 8, then 1 plus 1 9, then minus 9 is gonna be 0. This one with this 8 and 3 will give you 11, 11 minus 3 8. So this is what I'm getting after multiplying with these two metrics. That I can clearly see that AC is equal to what? Can I write 8 outside and I will get 1 0 1 0 1 0 0 0 1? So I can write it as 8i. Can't I write like this? AC is equal to 8I, isn't it? Okay. Now take, okay, anyway, what I want to see, I want to get A inverse from here because I need to solve this one. So I need to take for find A inverse. So I'm gonna multiply both the sides with A inverse. Fine. Thus I get over here A and A inverse I. So you know it's gonna be C here, and 8 could be taken down, and this will be I and A inverse will be A inverse. That's what I am getting here, which implies A inverse is equal to 1 by 8 of C. So this is what your A inverses. So from here clearly I'm getting A inverse as 1 by 8C. Now this one is what you need to use it over here. So from these equations, what I can write here, from here I can write the same thing over here, like 1 minus 1 1, because earlier itself I have checked whether it is it is like gonna be this matrix or this. Okay, now this is the one. So 1 minus 2 minus 2, 2 1 3, so that is a matrix what I have here, should need to be multiplied with the x matrix, which is x y z, and thus I get a value which is all these results 4 9 and 1. It's gonna be 4 and 9 and 1. Clear? So this is what I'm getting. Now this is A, this is B, and this is X, and this is B, isn't it? So as I know that AX is equal to B, what I can write, X is nothing but A inverse of B, isn't it? This is what I need to find from here. Clear? Now for finding X, what is A inverse here? A inverse is nothing but 1 by 8 of C. So 1 by 8, and what is C here? I've taken this one as C and this one as A, so this is C. So minus 4 4 4, minus 7 1 3, 5 minus 3 minus 1. So this is gonna be my matrix, which is A inverse into B. What is B here? B is nothing but 4 9 and 1. So these two need to be multiplied together in order to get the matrix which I require to find the value of x, y, and z, so that I can solve this equation. Fine. So when you multiply, okay, let's see with the multiplication. Minus 4 into 4 is gonna be minus 16. I have minus 16 here. 4 into 39 is gonna be 36. So 36 here. Then 4 into 1 is gonna be 4 plus 4, and this, okay, now this get cancelled, like 12 is left. So 12, if I subtract from here, it's gonna be 24. So 24 there. So I have here what? I have here 1 by 8 itself. I will just divide it later. Okay, I will just divide it later. So this, when we do it, it's gonna be 1 by 8 into 24. It's gonna be 24. Again, if I want to check, okay, like, yeah, 16, like 30, like 20 is left, 24. Yes, correct. Then on to the second row with this column, I will get 7 into 4s are minus 28. 1 into 9 is 9. So from here, if you solve it, it's gonna be like minus 19. Then again a 3. So there you have a 3 need to be multiplied inside. So plus 3. So 12, if you take it out, so it's gonna be 16. Like 12, if I take it, like yeah, these two are giving me 12. So 12, if I take it, so it's gonna be 6 and 1, so 16. So I'm getting 16 here, and that too, is it minus? Yes, it's minus 16. Fine. The next one is 5 into 4 is gonna be 20. minus 3 into 9 is minus 27. This is going to be minus 27. Minus 1 gives me, like from these I'm getting minus 7, and 1 minus 8. So this is going to be minus 8. And when you multiply inside, what is the value of x matrix? X matrix is nothing but, okay, when you multiply inside, it's going to be 3, it's going to be minus 2, and minus 1. So what is the value of x? What you want it from these three equations, from here, from here, from here, when you normally. So this is actually the application of matrix there. You get to solve these equations. Fine. So linear equation, as you know, that when three variables are there, there is a hell lot of a thing which you need to just do it, because it need to make into two variable, then simplify, substitute, and there is a lot of steps which you need to follow in that way, like by substitution or elimination method which you follow. Okay, fine, but this is one of the method to get the value of x, y, or maybe more variables. If you have it, you can get it very easily, these values. So this is what I'm getting. So x is equal to 3, y is equal to minus 2, z is equal to minus 1. So this is what the values what is required in this question. Fine. And I have told you, you can have a check of these answers whether it is correct or not. Go for any one of these equations. 3, x is gonna be 3 there, minus y, so it will be plus 2, then minus 1 over here will be minus 1, so it will be like 1, 3 plus 1 is equal to 4. So that 4 is what is over here, 4. So that is correct. So this is my solution for these three equations. Fine, with the help of matrix. 2016 26th question. It's a 6-mark question, and one of the important questions even. Now it's asked, like, using properties of determinant, prove that determinant x plus y the whole square, zx, zx, and the whole determinant is equal to this determinant, this value here. So this is supposed to prove. So I will just write it over here again. So that's why I was not uh, reading that one. Okay, the entire determinant. So I'm gonna write here what are the values for it. It's gonna be x or yx plus y the whole square, zx, zy. So over here, all the other terms xy, and z is not here. The other one, zx, z plus y the whole square, and xy. So here I could able to find this term doesn't have x terms, and as I have told, okay, now after writing this one, zy, xy, then z plus x the whole square. So this is my determinant. Fine here. Now what I have told you was on the other question, okay, was if I get to see something to be proved like this, and you can get to see a diagonal element with all the other elements almost or equal to, yeah. In such a case, operations like if I do it with the columns, if I do it with the rows, is nothing gonna change much. The steps or what you need to do should need to exactly aim at finding this particular value in this question. That's what your ultimate aim must be, to find, so reach over here. Fine. Okay, let's try this one. Now if I look this one in different way, I could able to see that if I subtract and all, it's not gonna work. Okay, I'm gonna make a slight bit adjustment over here. Okay, look what I'm doing. I'm gonna multiply the first row, because z is here. I'm gonna multiply z here. Okay, I'm just gonna do something a bit different. You might see like why I'm doing so. Okay, you will get an idea of it there. I'm gonna multiply here, so it will be like z over here, and over here I'm gonna multiply with an x, and over here with a y. So x, y, z, I'm gonna multiply into each of these columns. So it will be, if I multiply over here with z, it's gonna be z into x plus y the whole square, and this will give me z square x, and this gives me z square y, isn't it? z square y. And over here, if I multiply with an x, because x is not here, so if it is doing with x, so it's gonna be z x square, isn't it? Z x square, z x square, and this second term would be x into z plus y the whole square, z plus y the whole square, and this is gonna be x square y, x square y. Then the other term would be like if I'm multiplying with an y here, so it will be z y square. Then this will be like x y square, and this term will be y into z plus x the whole square. Fine. So this is where I reached. Fine. And where I can clearly see that now I could able to take away z from here, because I multiplied over in this column. I'm gonna take it from this column. That means I want to get rid of these z's here. Okay, like let's see like what is the impact, what is gonna make z from here, x from here, and y from here. So if I take it outside, it's gonna be x y z in the numerator. Denominator already we have x y z, and the determinant thus becomes, what is the determinant now? It's gonna be like z gonna move out, so it's gonna be x minus y the whole square, and this is gonna be giving me a value x square, and y square, this z went outside, so it's gonna be y square. And over here, okay, x is moving out, or x is being taken out, so it is z square here, and this gonna give me z plus y the whole square. Yeah, and this one x went outside, so it's gonna be y square here. Clear? So this one is z, this one x, and this one y z square. This is gonna be x square, and here it's gonna be x z plus x the whole square. Yes, fine. This is how we have or this is where we have reached. Now clear? Now what next? This could be cancelled that easily, like we could cancel these two, but what to do with the determinant now? Now what I'm gonna try to do is that, okay, I'm gonna change this C1, and I'm gonna change this C2. What I'm gonna do here is that I'm gonna subtract with, because if I subtract x square with this x square, this term is gonna be 0. That is how we look, right? The first term, I don't need to make it 1 right here. Okay, 1 usually used to think when it's been asked to find a matrix, like a matrix is given and you are asked to find A inverse through elementary transformation. Yeah, elementary row transformation. Those questions you will try to make it an identity matrix, but here you don't need to think like that here, but you need to try to make as much as elements as 0 as possible. So here if I subtract it, so what I'm gonna do is that I'm gonna write C1 as, yeah, C1. Okay, C1, what I'm gonna do is that I'm gonna write subtract C1 minus C3, this with this, and I'm gonna change the C2 into C2 minus C3. I'm gonna do it with this. So C1 minus this and C2 minus this. Okay, what we are up to after that? Okay, we reach, okay, when I do such a thing, it's gonna be, okay, very quickly we will write x plus y the whole square. This is gonna be like when I subtract it from here, so z square, then x square minus x square is gonna be 0, y square minus z plus x the whole square, That is the first column. Then the second column, when you subtract these two, it's gonna be giving me 0. Over here it could be z plus y the whole square minus x square, Then this one gives me y square minus z plus x the whole square. Z plus x the whole square. Then the third term will be as same as z square, x square, and z plus x the whole square. Fine. So this is my determinant right now. Any doubt? Clear? Now, now I reach here. I don't have anything else. Now I need to try to reach over here, dear. And as you, okay, you know this formula, right? A square minus b square. A minus b into a plus b. Okay. Can't you see something like that? This is a and this is b, as in so many cases over here. So can I write this a square minus b square into a square plus b square? So this term, okay, I will write 1. Okay, after that you can write it by yourself. Now in that case, what, okay, what I can try, can I write this term as like this, the whole square minus z square? Can I write like this, x plus y minus z and x plus y plus z, these two factors? I can like use this formula and I can split it into two, right? Two factors. So there is a term which is coming x plus y plus z, isn't it? Over here also you can see that there is one term which is y plus z plus x. Here too you can see z plus y plus x, and here too. So I'm gonna take one from this column, I'm gonna take that particular term outside, and from here the same term, this term will be there in this, this and this. Check it, you will get it. So if I'm taking both, like one x plus y plus z from this column and from this column, I can write it's gonna be x plus y plus z the whole square. So I'm here it is cube, but I reach square now. Then the determinant, where right now what is the values? If it goes outside, it's gonna be x plus y minus z, isn't it? Minus z, because plus z came out. This is gonna be 0, and here it is gonna be y minus this term would be x minus this complete term, right? So it will be minus z minus x, because everything else is over there itself. Fine. Then all the way down here, this particular column, it's gonna be 0, 0 itself. Then onto this one, z plus y, then minus x is left. Then onto this column, this row, you can see what is left, y minus z minus x is left. Then here z square, x square, z plus x the whole square. So this is my determinant right now. So this is my determinant. Clear? So these ones was just to make you understand here. Yeah, these ones are just to make you understand. And this is where I reached. Now after this one, so I have this term. Now what we can do with this then? Do you have any idea? Now these two become 0, but mostly we will try to make these two 0, yeah, so that my finding the determinant value of this particular determinant, the value of that or delta of this one, is pretty much easy. So we normally don't try to make this one 0, but in fact we make this particular term 0, yeah. As you can see over here, now as I have told you, this I need to make it 0. So in order to make this one 0, what you can do is that you try to subtract from the first year. When you subtract, what you're gonna get? You're gonna get something like y and y get cancelled, because this term, this become minus. The first and two terms will become minus, and this will become plus. So that one will be cancelled out, and this one cancelled out, and the x will be the term. So it will be much simplified simplified version of this one. And again, like so this cannot be 0, but I can like make it reduce into small, okay, and this one will this 0 will change to this y minus z minus. This is something which I'm thinking, okay, which the same concept you need to think. I can normally write it, but it would be better that if you think logically, like how can you do it, how can you apply it. I can simply write okay, now c2 c2 3, like that way you can just simply write it if you know it, but it's just simply good to look at how to do it. So this one 0 will be vanished if I subtract it. So I need to like make this one 0 or much more closer to 0 here. What I'm okay, I two times I'm gonna subtract this. Instead, what I can write is that C3, not C3, R3. I'm gonna okay, R3. I'm gonna change it to R3 minus. Okay, I would have done like I would have subtracted these. What I'm gonna do is that R3 plus R3 minus R1 plus R2 together. Let's add these ones and then subtract, because here when you add it and subtract it, you could able to see that a lot of terms will vanish. Okay, let's see like how we can get rid of that one. This will be x plus y plus z itself, the whole square, and onto the determinant what I'm getting here is okay, and if you do such a thing, okay, I will do the calculation this side. If you okay, if you add, this is gonna be, these two terms are gonna be the same, x plus y minus z. This is gonna be like 0 z square. This is gonna be like 0 z plus y minus x. This one is gonna be x square itself. Fine. And the last row R3 is gonna be, you're gonna add in this one and gonna subtract it. So it's gonna be subtracting minus minus and plus. So the minus and this will get cancelled, the plus and minus will get cancelled, and this will be minus, and this you will get minus 2x. And over here when you do it, these two things added, okay, the same thing subtracted, so it will be plus x, it will be cancelled up, minus z cancelled, then minus y, okay, it's gonna be like a minus y minus z. So when you subtract it, it's gonna be like a y minus z, so it will be minus 2z. You can check it, like this will be minus, so minus 2z, the rest of the terms will get cancelled. Then over here, if you okay, not this one, I can write this one as z square plus 2zx plus x square, right? And if I subtract it with this and this vanishes, and you will get 2zx. So it will be 2zx. That will be your determinant as of now. Yes. Now what I'm trying to do is that I'm trying to uh, okay, okay, fine. Okay, we will continue from first. That'll be good because I don't have much space over here, so we'll just do it again. Do from here. Now what we can do here. Now again, I have told you that we need to make this one 0 here. So in order to do that, if you check uh, here, I have two x's, right? What if I multiply the entire column with an z and this one with x? These two are gonna be the same. So thus I can add it with this one and make these two 0, can't I? So let's try. That is equal to, I'm gonna multiply this column with z, okay, and this one with x. So when I multiply, I'm gonna get x plus y plus z the whole square, and in determinant, this one I'm gonna multiply with an z. So it will be okay, fine. I will just multiply inside and I will write. It will be like x z, yeah, z plus y z plus z square, right? And this will be 0, and this one will be 2 x z. Now 2x is it. Here the second column will be with x. So when you do it, you need to divide it over here because you are multiplying it and z here, so you need to divide it. Again with an x you are doing it, so you are again gonna divide x. Fine. So this one gives me, okay, you are multiplying x here. So 0, and this one gives me the second one, xz plus xy minus x square, and this will be minus 2xz because there was no x there. So now I could able to see now the third. Okay, the third I didn't change anything, so xz square, x square, and 2xz. This is what the interesting part is. These two are obviously equal to this, so you can subtract it. So what I'm gonna do here, I'm gonna subtract C1, okay, not subtract, I'm gonna add because this is minus and this is plus. So I'm gonna add with this. I'm gonna change C1 with this. C2, what I'm gonna do the same thing, C2 minus C2 plus C3. So thus this determinant gives me x plus y plus z the whole square by xz, and the determinant thus becomes how much? Okay. This gives me, you're gonna subtract, you're gonna add this one. Okay, and one more thing here, there was a change in sign and this was minus here. So that will be cancelled with this minus and minus, and thus you will get these two terms, and from there I can take z outside. I can write z into x plus y, isn't it? The first term, because z square minus z square and this one got to be cancelled. Yes, and again with this one, and I'm gonna get this plus this, right? So again x square is gonna be x square, and added with this obviously 0. That is our intention, right? Then what? From here, this and this gonna add, and this already we have done. This already we have finished. We are moving to the second column. So it will be like z square. Now adding up is x square and x square get cancelled, and you will get to see that x could be taken outside, and you will get y plus z, isn't it? From here, y plus z common if I'm taking x. This again, like obviously it's gonna be 0, and over here it will be z square, x square, and 2xz completed. Fine. After this, what? Okay, shall we, like, what we will do is that we'll expand this. And we will see like what we are gonna get. What else we can do here? One more step we can do, that is we can take, you can see like z square, z is here, x is here, and xz is here. So I can take these terms outside, right? So the first column I'm taking z outside. So what I will be getting here, already these terms are there, x plus y plus z the whole square is there. I'm just waiting the square to make it cube, okay, and the other terms. That I think like I will be getting it when you solve the determinant. Then xz is already here. X z from the first column, I'm gonna take z from here. Like I'm gonna take it outside. So it will be x z here. From here I'm gonna take x because I can see x square, x and x square. So I can take an x, and thus you can see it could be easily cancelled with this xz. And thus what are the terms left? X plus y is left. Then z went, so it will be 1z. Here too 1z, and here I'm gonna get an x because 1x went outside, and this one xy plus z, x went outside, so x. Then here 0 is there, 0, and over here, okay, nothing, I'm not gonna change anything, right? 2x is it, fine. Now expand it, yeah, expand it. Let's see what we are gonna get. Okay, already x plus y plus z the whole square is there. What is left with the matrix inside us? This term is there. There is gonna be x plus y is there. That's gonna be multiplying with these terms, these two. What are these two terms? I will expand it and write. It will be like 2xyz plus 2xz square. Right. I think I'm just doing it fine, I think. Then minus z is there. Minus z, the other one. Into, you have this term. Okay, you can multiply, and here it's gonna be 0. So this 2x square is z. Fine. So that is what we have it inside. And thus, what we are up to right now, x square x plus y plus z the whole square into, if you multiply inside, I'm gonna get with this one, it's gonna be like 2, anything else which you feel it like it is a little awkward. Okay, let's multiply inside and let's see. Okay, what we are gonna get, it's gonna be 2 x square yz plus 2 xy square z plus this term is gonna be like 2 x square z square two xy z square minus 2 x square z square. So this is the term. Now cancel these two. Then what else we have here? Okay, we have these three terms. So can't I take 2xy from each one of these terms? From this xyz, xyz, xyz. Fine. And then what is left now? This is square already. 2 went, x went outside, 1x went outside, so it will be x here. From here, z is left. So these three become x cubed. So that will be z. Hence, proved. Fine. This is how you to solve this 26. 2016 26 question. It's an OR question. Like if you cannot do the other question, you can try this one. This is quite a bit easier than the much easier than the other problems. If maybe like some students may get confused in that because there are a lot of interchangings of like rows and columns. So this one is way easier than the other one, but only the thing is that little lengthier when you compare to a cube and all. Okay, what is the question here? If a matrix is given 1 0 2 0 2 1 2 0 3 is the elements, and a cube, it's given that a cube minus 6a square plus 7a plus k I just of an order 3 is equal to 0, then find the value of k. Then find k. Fine. Anyway, we want this a cube and a square. A is already there. This one we don't need to worry much. So these two need to be found first. Okay. So first let's deal with a square first. So a square is nothing but 102, 021, 203. That should need to be multiplied again with the same matrix 102, 021, 203. Right. Yes. When you multiply, what are you gonna get here? Okay. Okay. Fine. I will just write it like this. That is equal to, now first row into first column. So 1. Okay. Maybe like I will write it in full. This one. It's okay. Like okay, you know it, right? Okay. 1 into 1 is gonna be 1. Then okay, I will write it here. 1. 1 into 1 is 1. 1 into 0 is 0. And then 2 into 1, 2 into 2 is gonna be 4. So plus 4. So the first element is 5. This is 5 here. Yeah. So this first row with the first column, that is 5. Now with the first row with the second column, 1, like 1 into 0 is 0, 0, then 2 into 0 is 0. Again, this is gonna be 0. This first row with first column, that's why like it is a little more easier. That's why I'm not just adding it. First one with the third column, 1 into 2 is 2, then 0, then 6. 6 plus 2 is gonna be 6 plus 2, 8. Right. Then the second row with the first column, 0, 0, then you have 2 here. The first one like 0, second one with the second column, 0, 2 to 4, 0, so it's gonna be 4. The second row with the third column, 0, 2, then 3, it's gonna be 5. Third row with the first column, 2, 0, 6, it's gonna be 8. Right. Then the third row with the second column will get you to 0, 0, 0, and this will be 0. And here, what you are getting? 2 with 2 is 4, 0, then 9. 9 plus 4 is 13. So this is what my a square is. Clear? A square. Now what I'm gonna do with finding a3? A3 is nothing but a square into a, right? So I already have found out 8, 2, 4, 5, 8, 0, 13. So this is already there. What I am supposed to multiply with? A, which is 1, 0, 2, 0, 2, 1, 2, 0, 3. I'm gonna multiply, and thus what I'm gonna get here? I'm gonna get, okay, let's see. 5 ones are okay. The first row with the first column, 5, 0, then 16. So 16 plus 1 is nothing. So 16 plus 5. So 16, right? Yeah, 16 plus 5, 21. Then the other one, the next first row with the second column, 0, 0, 0. So this is gonna be 0. And in the next one, this first row with the third column, 10, 0. This is gonna be 24. 24 plus 10 is 34. 34. Then all the way to the second row, 2 into 1 is 2, 0. Then 5, this one 5 twos are 10. So 10 twos are 12. So I have 12 here. So second row with the second column, 0, 0, 0, and this will be 0. And this will be 0, right? 0, 0, 0, yes. And the next one with second row with the third column, 4, then 4, 4 and 4, 8, then 15. So 15 plus 8 is 23. So you have 23 here. Then what else? Okay, these two multiply together. Okay, now the third row with the first column will get 8. Then this one 0. This one gives me 26. 26 plus 8. 26 plus 8 is gonna be 34. So you have a 34 here. Again with the row with the next column will give you 0, 0, 0. So this will be 0. And thus the next one is what is gonna be 8 twos are 16. So this is gonna be 16, then 0. Then this is gonna be 39, right? 3, yeah, 9 and 3, 39. 39 into, with this one, it's gonna be 16. 16 and 31, like 39, like 5, 1, 4, 5, 55. So this is gonna be 55. Fine. Any problem? I think it's pretty much clear, right? First you figured out what is a square, then the a cube with multiplying with the answer what I got it from here, and thus I got now a square and a cube and a square here. Now it's just time to just simply like put it in the equation over here. So what is the equation here? A square. What is a square here? It's gonna be 21. So 21 0 34, 12 0 23, 34 0 55. This is gonna be subtracted with 6 into a square is nothing but, we already found it here, 0508 245 8013. Yeah, this one I have it, plus 7 into a. What is a here? 102021, then 203. Okay, this matrix, the first A matrix, then plus k into I3. So k into I3 is 100010001. So this is here I3. And now what I'm supposed to find? K. And this is nothing but a cube. Yeah. This is minus 6 a square. What is given in the question here, and plus here is 7 into, this is your a plus k into your I, which is on of order 3. Fine, that is, all these things are gonna be giving me k. Now how to find k? Just relate the terms here. The first element, which is 21, minus 6 into the first term over here, yeah, that will give me 30. So minus 30 plus 7 with this first term, first element over here, so that is plus 7, plus k with the first element over here in the identity, which gives me k, and is being given that it is equal to 0. So when such a thing is given, that when such a thing we got it from this equation, then we can easily solve it for k. So when I add up all these things, it's gonna be like 30, like here I have 9, then it's gonna be minus 2. So minus 2 plus k is equal to 0, which implies k is equal to 2 will go that side and give me, minus 2 will go that side and give me k. So this is the value of k. Thus you find the value here. So what you did here, a square you found first, then a cube you found. So here I have a square I found first, then the a cube I found it from here, then put it on along with the equation. From there, take the element, select that element. I cannot select this one. Why? Because this one I cannot do it, because k into 0 is 0. So from there I cannot find what is the value of k. So pick that element where I can get a value k, which would implies, or which would give you, like, which would is equal to, or that one is equal to 0, and then substitute and find the value of k. Hello dear students, now these are the important questions which I have referred, I have worked it on from so many resources and got this one. And make sure that you spend a bit of time onto these questions one by one, and if you see it, okay, it's easy, you know to do it, leave it. But make sure that a lot of other questions that just like these ones, just practice a bit more, okay, because this time you can expect any one of these questions from what I'm giving you. So around 20 questions I have selected now. In matrix, make sure that you practice all these questions and go for the exam. And the first one was like a and b given, verify it is like, okay, a b dash is equal to b dash into a dash. So that is very simple that you can prove it. Then the other one is to prove like this determinant is equal to this one. Prove it. This is equal to this. This is equal to this. This determinant is equal to this one. Prove it, dear. And as I have told you, and you can expect a sure question from there, that a matrix is given which satisfies the equation. Okay, this one. Hence, find A inverse. So, from equation is given from here, you substitute all these values of A, make find A cube, then A square, A cube you find it, then A square you find these ones, and put it inside the equation, equate to 0, and from there you find A inverse. So that we have done, and make sure that you practice that question. And over here the same thing, like again an equation, from there A inverse you need to find here. Then these are the first 7 questions. Then move on to the second, that 8. Make sure that you pause the video, take a piece of paper, write on it, make sure that you practice it, make sure that you know it well. Whether you do is the secondary thing, but I recommend you to do it, but make sure that you write and see. If you know it, it's okay, you can move ahead, you can go for the next question and you can practice. Over to the 8th question. If A is equal to such a matrix, then show that A inverse is equal to A square. So you need to find A inverse, then A square, you need to compare them and they must be equal, then show that. Fine. 9th one, use the elementary row operation, find the inverse, that we already have done, you need to know it. Do practice this question. On to the 10th one, construct a 2 by 2 matrix whose elements are A, J, R given by this. So there are 2 conditions given, and as I have told you over there, you must be very sure about how to or what are this A, I, J. A, I is the first row and this one is the column, fine, and this one is gonna be like 1, 1, and this is gonna be 1, 2, like that it goes, and this one is second row, first column, then this one would be second row, second column, like that way. So if condition is given that if I is equal to j, that means nothing but it's a diagonally like 1, 1, 2, 2, 3, 3, like that way. If they are equal, you need to take this condition, or else you need to apply your I and j value over here and get the values and put it in that matrix which is asked. Now it is 2 by 2. If they are asking 3 by 3, you need to do that one. Fine. Nip out. Okay, then on to the 11th question. If delta such a thing is given, then delta 1 is equal to this. Prove that delta 1 and delta 2 is gonna be 0. So you need to do the transformation over here. Try it. It's a question from exemplar, which is very important this time, I hope. Make sure that you try that one, dear. Okay. The 12th question. Using the properties of determinant, then prove these two determinants are same. Then so with the properties of determinant. Okay, make sure that you do that one. Properties of determinant. Then that is very important here. Okay, make sure that you do it. Then 2 matrices are given, A and B. Verify AB is equal to BA is equal to 6I. You need to verify this thing. Then I is a unit matrix where of order this one, and then solve these equations. So make sure that you do this question. Okay, make sure that you do this question, and that's an important one, dear. Now earlier what we had discussed about these 2 questions, like I and J is what is given. Then according to this formula over here, what is given, you need to substitute the value of I and J, and then you need to make 2 cross 2 matrix. Fine. Over here also, but here it is not 2 cross 2, but it is 2 cross 4. They need to make 2 into 4 matrix with this formula given here. Substitute each place do have a certain value that you know, A11, A22, like that way. Substitute the value of I and J, hence you will get all the elements of that matrix. This one too, find the value of x, y and z. From this you need to equate. You need to equate to the different elements. You need to compare it and to find these values of x, y and z with different equations. On to 17th. If A is equal to minus 3, 2, 0, 1 and B is equal to 0, 3, minus 1, 4, find the matrix X such that this is the one. So you need to find the matrix X. Fine. Yes, that you need to substitute. You need to keep X here and then rest of the things other side, then equate it. Fine. On to the 18th one. Construct a 3 by 2 matrix whose I and jth element is this one given. Substitute that I and j value and you will get that matrix, and it is gonna be 3 cross 2. Fine, 3 into 2 matrix. Here this type of problem we already have solved, and in this sample question paper it is given. So you are supposed to find the value of lambda here. So lambda is what you need to find. Just take it out. You will get to see like what is the value of lambda. Then so when you are taking it out, it will be like lambda cube. Lambda cube is gonna be like this. Then okay, then you can solve it. Find the value of determinant. We can find easily the value of this one, and this one is also very important question, dear. Okay, very important question. Where X is already has been told that it's a root, so one of the root is like a -4, and there is a determinant given which is equal to 0. Find the other two determinants. So other two roots you need to find it from here.